Everybody to what is the 500-something workshop at Frontend Masters. We are here for interviewing intensive course with Evgenii. We're going to go very, very deep. He says today is going to be somewhat deep, but tomorrow we're going to go really deep. So that's going to be great. If you have any questions on the chat room, feel free to ask, and yeah, we'll get that over to Evgenii. We have over 100 and I think it's like 120 people from around the world in chat, and more people joining us from the stream. So hello to everybody, and yeah, excited to get going. So take it away, Evgenii.
All right. So, all right, folks, welcome to the front-end interview preparation workshop. My name is Evgenii Ray, and before we start, let's just kick off with a little bit of introduction. So I work as a staff UI engineer at Meta. I've been involved in UI development for the last 10 years. And I know that interviews are hard, and especially in the last few years, because the industry changes so fast. We've been seeing how the interview process changes for the UI engineers and for everyone. So in the past, you could get away with potentially like the good knowledge of the JavaScript and some framework. But now things have changed, so interviews became more demanding. So you're often asked to write some mini apps on the interviews, and in terms of how much you need to code, the expectations have also risen a lot. So this course is about learning through the practice. So about 80% of the workshop, we just go into code. So we're going to split between the slides. Sometimes we go to refer to the slides when I need to explain to you some complex concept. But for most of the course, we're basically going to code. So before we kick off the main part of the workshop, so let's just review the interview process for UI engineers. So usually on a stage one, you just start with the HR call where your CV is reviewed, and basically HR determines if you're a fit for position. So the technical screening starts on the stage two. So you often ask like to do one or two interviews. One could be the UI coding, where you code some simple component, and the second one is data structure algorithm classic interview. So depending on the company, companies ask either two, maybe one round. So it really depends on where you're applying for. On the stage three, which is the virtual on-site, usually it's the system design. So depending on the position you're applying, it could be the full stack system design, front-end system design, or back-end system design. Then we have the JavaScript coding. The JavaScript coding involves usually just building some function that is well known, like replicate some Lodash function or part of the promise. And while the component UX coding is usually where you are given with some Figma mockup, and you need to build everything from scratch. And you also have the algorithmic coding. So the last part is the behavioral interview, where you are tested on your soft skills and how you resolve the conflicts within the team. In this workshop, we're going to focus on these parts. So first of all, I'll teach you how to solve any component problem using either React or vanilla TypeScript. So after this workshop, you'll be able to solve basically any problem using the framework that I will provide. And also, we'll start our workshop with the warm-up section to help you with the JavaScript coding. So we'll just review some of the most popular questions related to JavaScript coding. On the agenda, so we'll start with the JavaScript coding. So I'm saying JavaScript, but it's actually TypeScript. So throughout the course, we're going to use the TypeScript. But the TypeScript coding will be just at 20% of the workshop. So it basically serves us as a warm-up, so to get comfortable with our keyboards and so on. So, and then we'll start with the basic components. So the basic components are the components that usually ask on the FAANG-like interviews. And the real challenge starts with advanced components. So advanced components usually are the components that require you to know some certain web APIs or the concepts or the patterns to implement. So it's not very simple. So it's usually where you need to build the mini application from scratch. So these are the questions that I usually ask in some finance companies. The last section is the stuff plus coding problems. This will be our kind of boss problems. So we're going to build the ChatGPT-like interface with data streaming. So we'll learn how to parse the binary data from the markdown to the actual HTML. And the Google Sheets problem, it's where we kind of try to create a simple clone of the Google Sheets. So we'll go through the parsing the formulas to the topological sorting of the dependencies, how we calculate this using the reverse Polish notation, and tokenization. And then we'll finish the table engine. We'll build the simple UX and UI for the Google Sheets. And across the workshop, we'll also face some TypeScript challenges. The reason why I included the TypeScript in the workshop is because TypeScript is becoming the de facto standard across the industry. So, and I think it's critical for us to actually know how the type system works. And like every 2-3 problems, we'll face 2-3 TypeScript challenges, and I hope that it will give you some good understanding on how to work with the TypeScript type system. So one thing to note, the problems on the workshop, yes?
Oh, just how has AI generally affected interviewing? Do you feel like it's...
So right now, the companies kind of split. So some companies still ask classic UI interview questions, but they ask it for like more deeply in terms of you need to build the kind of micro apps from scratch.
Sorry, the buzz. Could you repeat?
So right now the company is split into the kind of divide into 2 parts. So some companies still ask the classic JavaScript and questions, but they change the approach. So instead of asking some maybe small functions, they actually ask you to build something meaningful, like a mini app, and they give you more time, like 1 or 2 hours, instead of like 45 minutes time frame. And some companies, they now prefer to give you AI assistant, where you can prompt engineer 80% of the code, and then you need to kind of check what's AI generated and finish the problem yourself, and be able to reason about the code. But one thing is still there. You are still tested on your practical skills. If you don't know the patterns, if you cannot explain the code, and if you don't know the technology itself, then you will fail the interview. OK, so one note about the problems on the workshop. So you will see that the problems are actually quite hard. So the first section will feel a bit easier because it's mostly for our warm-up. But once we ramp up the difficulty, you will see that you might not be able to understand the problem on the first attempt. So what I suggest is try to watch the recording later, go through the diagrams and explanations, and then you'll be able to understand things. So I've intentionally increased the complexity of the problems to make your future interview more manageable. So the reason for this is when you come on interview, so your mind just switches off. So we all have like nerves. You will be stressed, and it's very hard to think clearly. So I myself, I'm very bad at the coding interviews because I'm so anxious when I do the interview. So once I come after the interview, I was like, this was easy. So why I couldn't solve it? So that's because you have nerves. And if you train yourself on the harder problems, you will be able to better manage the stressful situation in your future interviews. In terms of the complexity, we'll face I've split the problems into the 5 categories. So the first one is basically warm-up questions. That will be the TypeScript challenges that we'll face. So it's just 2-4 minutes, basically it's just warm-up questions to make you comfortable. So the easy questions are usually asked on the interviews on the screening. So you could get like 3-4 questions, and usually it takes like 5 to 15 minutes to solve them. And there is a medium question. So most of the interviews will contain medium complexity questions. So it usually takes 15-20 minutes to solve them. So luckily for us, 70% of the workshop is actually hard questions. So that's where you need to know all your APIs, edge cases, and also you need to use the right architectural patterns in order to solve the problem. So on the interview, it takes 45-60 minutes to solve. On the workshop, we're going to target like 25-30 minutes instead. So, and also we have our boss problems, which I call extreme complexity. So this is the problem where you need to split the whole problem into the subparts. So for instance, for Google Sheet, we're going to split this problem into the 5 sub-problems before we actually solve the whole thing. So these are the problems that I ask on the staff level interviews, and it takes around 1 or 2 hours to actually resolve. Usually the way this problem is asked, you can access the internet, you can access the Stack Overflow and just ask questions about the APIs, but you still need to build the whole thing from scratch. So you need to download this repo on your machine before you continue with the course. So this repo will contain all the problems that we were going to solve, and we're going to use this repo throughout the whole workshop. The best way to follow the course is to use any IDE. So there is no restrictions on which IDE you use. You can use VS Code, IntelliJ, WebStorm, doesn't matter. So anything that you're comfortable with. My only ask will be to disable all AI assistants. So first of all, you're here to practice and learn, and not to get the solutions from the AI. You need to build these practical skills on your interview, because on your interview, you will not have any AI assistants. And also, during the course, we'll mostly likely face some mistakes. I don't have any notes on each problem, so I'm going to solve each problem with you on the live. So this means that if something doesn't work, we're going to debug it. And it might take a while to debug it. And also one thing, this is not a CSS course. We will not waste the precious time on styling our components. So basically, we will provide some very minimal style just to make the components work. That's it. So our focus will be on logic and the structure. If you download the repo, you will see that each problem kind of has the self-contained module. So each problem has its own folder, and within the folder, you will find that we have the solution, which you can reference. That's the reference solution. And there are tests. And the tests are executing your solution and the reference solution, so you can compare your solution against the reference one. So if we're solving the vanilla problem, which is just writing some subfunction and so on, so there will be no React code. But if there is a component code, then we'll have 2 files. Essentially, one will be vanilla.ts and another one react.ts. So each problem is solved both in React and vanilla. So during the course, we're going to switch between each. So you have the practice solving the components using both techniques. But once you watch the course, you can watch it again and solve all the problems in both in React and vanilla. In order to run the test, you can either use your IDE to run it, or you can use the bun command to run specific test file. So this project is set up with bun, so it should be relatively easy to run things. Okay, so since I mentioned that this course is not CSS course, there are some default imports that already imported in the student files. So this is just some basic CSS styles that we can use to kind of save the time. So just some flex boxes, spacing, very basic visuals, and typography. So we can use it in order to save our time on the styling the components. And here's the example, how can we use them. So we import the utility styles, then we import CX tools. What CX tool does, it just merges all the classes into one. So, and then you can set up your Flex container with the padding. So feel free to use that. Your solution might be different, so you don't need to fully follow my logic. So the components problem can be solved in many ways. Okay, so we start with the part one.
Before we get into that, quick question. How will this course compare to your system design course as well as something like lead code?
So in terms of the system design, so system design was more like fundamental theoretical knowledge that you need to pass. And it's all about like horizontal skills, technical skills. So this course is about UI coding, and the lead code is mostly focusing on the data structures. So we will not have any, for 99.9% of the problems, we will not have any data structures or lead code style problems involved. But comparing to system design, this course is like 80% practice instead of 80% theory.
Cool.
Okay, so let's start with our before we start solving the problems. I would like to propose some framework that you can use on your interview before you start coding. So first of all, when you're asked a problem, make sure you spend 2-3 minutes understanding the problem carefully. So you need to fully understand the requirements. And one crucial bit is what is the input and what is the output of the problem. So especially in automated testing, where you need to submit the solution and you have limited attempts to submit this, make sure that you fully understand what is the expected output. If you are live with the interviewer and before diving into the code, make sure that you're proposing multiple solutions if you have multiple solutions in mind. So the reason for this is some solutions might be better in terms of the performance, but in order to code them, it will take a while for you, and you might not be ready to code it during the interview. And solving it with the fastest method is not usually the right answer. So just make sure you compare these options with your interviewer, and set up the expectations. If applicable, so for most of the component problem, the space and time complexity is not applicable. But if you face this and you face some kind of algorithmic style problem, make sure that you discuss the complexity as well. Once you start coding, you spend 10-20 minutes implementing your solution, and if you have time, you will still need to test test the edge cases. So during the workshop, the tests are already provided, so we can just execute them and see if our problem passes all the tests. But on the interview, you don't have such luxury. So you'll still need to reserve some time to build some simple test cases and edge cases. Okay, so if you have time left, you can still try to propose optimization for your problem at the end of the coding round. This will give you some extra points because if the interviewer knows that, okay, you have some more ideas, that means you have a deeper knowledge, and so on. So yeah, if you have time, think about how you could optimize your problem. So let's start with our first vanilla problem, which is called detect type. So essentially, we need to build a function that accepts any JavaScript value and then outputs the actual type. So as you know, the type is determined by the constructor function, and we can have like many types in the JavaScript. So and the type of will not work in this case. So the naive approach, if we look at the way how can we solve the problem, you will see. So first we define the inputs and outputs. So the input is any JavaScript value, and the output is the lowercase string representing the type. If we take the naive approach, we can use that instance of operator to try to deduct the expected type. But imagine that you have like 100 different types, so you will need to update the function every time you add a new type. So could we kind of use a better approach? If this problem basically tests your knowledge of the JavaScript fields. So if we take any JavaScript value, in this case it's just 1, 2, 3 array, and then we try to get the prototype of this array, you'll get array.prototype. So array.prototype has the special field called constructor. So it's essentially the function which was used to construct this object. And because it's a function, this function has the field.name, which kind of gives us what we want. And if we scale this approach on every type, you will see that we actually are able to get all the types that we're from any object. And we can just lowercase it, and that we get our solution. That's the optimization that we could take here. And since we now know the approach, I suggest that we dive into the code and try to code it. So I'll move to my IDE now and open the first problem called detect type. And here you'll see that we already have the function that accepts the some value, and then it's expected to return this subset of the types. Okay, so first of all, let's handle the basic edge case. So what if our value is null or undefined? This means that it will not have any prototype. So we can just check if the value not strictly equals to null, because we want to cover both undefined and null. And then we can just stringify it like this. This will already handle null and undefined. So now we want to get the prototype of the value. So for this, we're going to use the default function called object get prototype of, and then we pass the value. So there is a case where the prototype is null. This is mostly you can only face it if you manually create an object like this and assign the prototype directly as null. So we'll need to handle this edge case. So for now, let's assume that the prototype exists. So we're taking our prototype, then we access the constructor, and then we access the name field. And if it's not available, then by default we just return object prototype, which is default prototype, which is default constructor function for every object in JavaScript. And we also need to lowercase this thing.
Evgeny, apparently the solution for this is actually filled out in the repo, so we'll need to reset that for the final course.
Okay.
But yeah, sorry folks, we'll reset that later, but you can delete the code and then start. But yeah, anyways, go ahead.
Okay, let's see why it's complaining. But before we see this, let's just try to run the tests. So if I run the tests, see some of them are failing. So this means something is wrong. So let's verify that. For that, let's just do the simple inlining to make our code a bit cleaner. Okay, so now we have our prototype. And let's just remove this. Then use proto to lowercase. And now let's try to execute a few tests. So this should give us null and undefined. So if you run it, so null and undefined are outputted, so this is correct. So let's also try to output some simple types. Now we're failing because, yeah, that's because we're trying to access the constructor without this field. Let's try again. See, now it's the object. And it's incorrect. Let me see where we're failing again. So we get our, oh wait. We don't have the prototype field because we're already accessing this. So let's try to run again. Yep, now it's outputting the correct value. And I think if we run the test now, it should work. Yep, all the tests passing. So that's the solution for our first problem. Do we have any questions on the stream? If not, I'm going to switch to the slides. OK, that was our first solution, first warm-up problem. Now we can move to the next one. This one will be easy problem. So the debounce is a very classic interview problem. Essentially, you need to build a function that ensures that your function executed only after the delay which is specified as a parameter. So usually you use the debounce function when you try to type into in the search bar, so you don't want to execute the HTTP request on every call, or you don't want a user allowed to execute the save button multiple times in a row. So, and in terms of the requirements for the problem, we need to make sure that we preserve the arguments that the function was called with, and the context. So the context can be attached when you attach the function to to a certain object and execute this function on the object. And before we jump into the code, let's first understand how the debounce works. So imagine that you're calling the function, and this yellow circle is a single function call. So you do the calls, and yes, nothing is wrong. So you basically you're able to execute the function every time. So, but then you decide to debounce the function. So when you debounce the function and you try to call it with to make a call C0 with the arguments, you cannot execute it immediately. So you will still need to wait for the time, and you need to set up the callback, which will be executed in 300 milliseconds. So you put this callback into the callback queue for the set timeout, and then you wait for 300 milliseconds, and then your C0 is executed. So let's run a few more examples. And if you run a C1, so C1 again is delayed, but then you decided to run a C2 callback. So 300 milliseconds hasn't passed, so that's why you need to replace the previous callback and the time. So you basically removed the previous callback and the time from the queue and placed the new callback with the 300 milliseconds delay. And same thing for the C3. Now C2 is removed and C3 is scheduled. And then you wait 300 milliseconds and C3 is executed. So that's the approach that we're going to take. And before we dive into the code, let's understand the inputs and the outputs. So input is a function and a delay in number, and the output is our debounced function. So our approach will be the following. Each call will cancel any scheduled timer, and then we'll reschedule the timer using the set timeout. So we're gonna return the timer ID, which will be the reference to our timeout. And we're going to use the clear timeout to clear this reference. And we'll also try to use the. We cannot use the arrow function because arrow function takes the context from the outer context. So we're going to use the full function. We're going to return the full function instead. And I'll explain it just in a few slides. OK, if we don't have any questions, let's go to the code and try to code it. So open the debounce problem and debounce.vanilla.ts. So here's our placeholder for the debounce function. So first of all, because we're in TypeScript, let's learn how to actually properly type things. What we want to do, we want to making sure that debounce can only be called with a function. So what we're saying is that our debounce should accept the generic parameter f, which will extend any type of the function and will return void, because usually all the debounce callback returns void. Now we need to provide the parameters. So the first parameter is our function, and then we use our generic parameter to type it. And then we pass the delay and use the number. So what we need to return now is another function. So we type it here like that. We pass the arguments. And now we need to return the function with the parameters that are exactly the same as f. So for that, we can use the TypeScript utility type called parameters. And then we pass our generic type f. And then it should return void. That will be our return type. And now it's complaining a little. Let's see why. Oh, OK, so it's actually nothing for now. OK, so now let's return our function called debounced. And yeah, I think there is a syntax mistake that I don't see right now. Yeah, now it's solved. So now we return our debounce function, and this takes the parameters of the.
One second. Somebody's dinging. I don't know.
It's actually my watch. 1 sec.
Oh. Just put it on theater mode.
Yep.
Sweet.
So now we provided the arguments with the parameters f. This will allow us TypeScript to match the function arguments that we are passing inside the debounce. And now, so what we want to check, so we first want to set up the timer ID that we will store in a closure. And we also want to properly type this. So for that, to type it, we're going to use the return type and then type of set timeout. This will give us exact return type of the set timeout function. And then by default, we'll assign it to null and also provide the nullest possible type here. OK, so if the timer ID is present, then we need to cancel the callback. So what we do here, we take our timer ID, and then we clear the timeout. OK, and our next step will be to set up the timeout. So we use the timer ID, and then we set the timeout. We pass our arrow function, and then we pass the delay that is specified as parameter. Now we need to execute our function that we are passing with the correct context. So we use the method called apply, which is available on function prototype. We pass the context object, which will be this, and we pass the arguments. So one thing to note here, see that the TypeScript is complaining that TypeScript doesn't know what this context is. So in order to solve this, we can tell the TypeScript, hey TypeScript, we actually don't care. So we don't know the context, but we want to execute this context with this. So this just makes TypeScript happy because we provided the type explicitly. And let's see why this one is complaining. So if timer ID okay, so now we're returning the function, and if we try to execute this example, you will see that it should only log C as a value. So let's try to run it. See, now it works. So it's canceled A and B as a calls. And if I try to run the test as well, so let's run the tests. So all tests passed. So this means that we solved the problem correctly. And before we dive to the next one, do we have any questions on this problem? Good. Let's move to the next one. So, welcome to the TypeScript challenges. Yep.
Yeah, there was a few questions around the TypeScript in the chat.
Yep.
Just wondering if you could walk through the types a little bit more in the previous solution.
Let's jump to the IDE. Okay, so the first thing is the generic parameter f. So when you set it like this, you're basically saying that the future type should have the following form. So it should be the function that takes any number of arguments and returns void. And then you use this generic parameter as f. So you will not be able to call your debounce function with 5, like this, because the 5 will not be correct parameter. So you're expected to get the type of any function. The next step is this, parameters f. So because we know that f is a function, we can type the future arguments that we're returning. So we're just basically saying that the arguments of the function that we're returning should match the function that we're passing. So this allows us to keep the same arguments. And yeah, basically that's it. Is there any more specific questions on that? We're going to have a lot of fun with promise. The typing there is hard. OK, so let's jump to our first TypeScript challenge. So basically, throughout the course, we're going to face these TypeScript challenges that should kind of give you a better understanding of the TypeScript system. So in this specific challenge, you need to build a generic type called length, which takes the read-only tuple array as a type, and then you need to output the length of this array through the type. So you basically need to return the type, which will be equal to 4. And this is our first TypeScript challenge. And now let's jump to the code. So let's open the first TypeScript challenge. Here the problem is 0-3 tuple length. OK, so let's start with basic generics. So first of all, we know that our length should accept the type, which will extend read-only array. So we're basically saying that, OK, our length generic should accept only read-only array of any type. And there is a huge difference between read-only array and just normal array. And the difference is the following. So when you construct a tuple like this, this constructs the read-only array. So what you're telling to TypeScript, you're basically saying, hey, TypeScript, so this array will never change. So you can basically statically analyze it and every element within this array will have a specific type. So instead of just having string array, and if you check the type, you see every element has a specific type. But this also applies for any property. So because you're using the read-only array, TypeScript can also infer any other fields on the array, for instance, length. So the array itself has a length property, which by default is number. But because we use the read-only array, TypeScript exactly knows the size of the array. So we can basically use a default TypeScript inference here. So here we're just saying that t.length, and all our tests are passing now. So as you can see, we now output the length of the array as a type. That was the first challenge. Any questions from the chat or the group? Okay. Next challenge. So our next challenge will be to take the same tuple and output the first type inside the tuple. So in case of the 3, 2, 1, we're gonna put 3 as a type. And if you pass nothing, like the empty array, then it should be output the type never. And here we're gonna learn another magic word of the TypeScript just in a sec. So open the next challenge in your IDE. This is called first of array challenge. And then we're applying the same logic. So we're saying that the generic that our first type can accept should extend any read-only array. So now, how can we detect the type of the first element? So you might say we can do something like this because the array is static. And for most of the things it will work, but if we have an empty array, then we are kind of screwed because, yeah, we cannot detect the type of the empty array. So now we're going to learn another keyword. So what we can say, we can ask TypeScript if our type matches the specific kind of the specific type. So in this case, we can say, hey TypeScript, does this array has the first element, and we don't care about the rest. And if it does, then please return the first type. Otherwise, we return never. So now we're learning about the magic keyword called infer. So what the whole thing here does is it's treated like a regular expression matching. So you're asking if your type matches the following type. So if the type has the first element and any number of elements after. So and then you use infer as a keyword to ask TypeScript, hey TypeScript, please give me the type of the first element. And you can return the first element as the type. And as you can see, all our tests now passing. Any questions on this one?
Just a couple of TypeScript questions. Is a tuple in TypeScript the same as an array?
They are mostly the same, but in terms of the tuple, this just basically means that the number of elements is known. So you can have like 10 elements in an array, and if you know exactly that there are 10 elements with this specific type, then you can call it a tuple. And if it's just a normal array, you don't know the length of the array, and you don't know exactly all the. So you can only know if the array has a specific type, maybe string, but you cannot know. You cannot narrow each element inside.
Why do we need to know the length of the array ahead?
This so the whole challenge is basically just to get basically to improve your knowledge about the TypeScript. So it doesn't mean that it will have the practical implications.
Is first a keyword? Likewise, can we say infer second?
Oh yeah, we can say anything like F1. So you basically say, so the only keyword we use is infer, and then you provide a generic name that you want to refer in your condition here. So it can be anything.
Oh, you're destructuring any into F1.
Yeah.
Right, okay.
And you can also destructure this one. So you can say infer tail. And the tail will be the no, it's actually because I'm not using this, he's complaining. So, and the tail will be the remaining elements except the first one.
Oh, that's cool.
Could you do the same for the second?
Yeah, I can do this. So I can say the first element should be any, and then I can say infer F2. And then I can get the type of the F2 as well. You can also do this, infer F1, if you want.
I'm not sure if we could take just a minute and go through kind of the setup, because a few people are not able to get the test to run and install the proper types and stuff.
So the only thing that you need to have is the bun environment. So, and then you can use the bun install. On the GitHub repo, there is a README. Let's just quickly check it.
Andres is saying in VS Code they installed the run extension and TS Node installed globally.
Oh yeah, so you don't need to use the node in this case. We're using the bun environment. So you need to set up. The VS Code to use the bun as the TypeScript engine.
Okay. Is someone saying they're getting an error on the import type?
Error on import type. Where?
Line 17.
On the tuple. Line 17.
I don't know. Yeah, it looks like right there. Yeah, that 15 in that case.
Is the group having the same issue?
You have to do bun install to get your dependencies,
Yeah.
right? So install bun, and then do bun install to get the dependencies, then it should be good. I'm good.
So just make sure you go for README file and execute all the steps. Then
Yeah, bun install and then bun test, and then the test file should work for tests.
yeah. Probably people trying to run through the IDE and they have the defaults.
And then one person said it worked once they restarted their terminal after installing bun.
Yes, you need to reinitiate the terminal because the environment variables only will load once you reload the terminal.
All right, I'd say let's continue. Yeah, sorry if anybody's having issues, but refer to the README, restart your environment.
Yep.
All right, let's roll.
Okay, so we solved our 2 TypeScript challenges. And the next problem is the throttle. So it's very similar to the debounce, but here instead of here the function should basically work like that. So instead of delaying the function every time we execute, so we have a static cooldown period where the function cannot be executed. So for instance, you have the period of the time frame, for instance, 1 second, and you want to execute the event every 100 milliseconds. So in this case, the throttle is your best friend. So, or if you're trying to build a game where you want to limit the fire rate of your gun, in this case, the throttle also is the way to go. And the requirements are mostly the same. So we have the function that we're accepting and the delay. So the only difference is we're not going to use any callback queue. Instead, we're going to calculate the time when the function was last executed and see if the delay is passed since the last execution. So that's the way we're going to solve the problem. So before we code this, let's just see the example how the throttle works. So imagine the same example. So we're executing the function. So the function executes normally. And then we want to throttle the function with a 300 milliseconds delay. So our C0 call is immediately called because the cooldown was not set up. So, but now, and then 300 milliseconds passed, and then C1 as well is executed. But now we're going to try to execute it more times. So C2, because the cooling period hasn't passed, we still have 200 milliseconds to go. We just canceled the C2 call. Same for the C3. So we're just calling we are canceling the C3 call because we still have 50 milliseconds in the cooling period. And then C4 is successfully executed, and then we set up the cooling period to 300 milliseconds. In terms of the inputs and outputs, so input the same function and the delay, and then we output our throttled function. And what we're going to do, we're going to store in closure the last time the function was executed, and then we're going to compare the current time minus last time to see if it passes the delay or not. If yes, then we run the function and update the last time variable. If not, we just do nothing. So that's the approach. And now I think we can go and code the problem. So let's open the folder 5 throttle.vanilla. And so we're going to follow the same process as with the debounce function. So first we'll define our generic f, and then we say that it should extend any function with any variables, and this function should return void. Okay, now we use the function f and delay. So we provided our first parameters. And then we return the function with the same arguments as f. So for this, we use the parameters generic and then pass f. And our function should return void. OK. So now we're going to return our throttle function. So we use the full function notation. And then we're going to access our arguments. So remember I said we need to store the variable inside the closure to make sure that we can track the time. So let's call it last call time, or just maybe last call. We'll initialize it as 0. So now we need to detect the time when the current time. So for this, we can use date now. So and now we need to subtract. So we have the last call, and now we want to subtract the delay from now, actually from last call. So we're subtracting from the current time, the last call time, and then what we need to check if it's more than the specified delay. And if it's the case, we call our function. We use the method.apply, pass this argument, and then pass the arguments that we provided. And then we update the last call to now. So that's it. And one thing to also to make TypeScript happy, we're basically saying, OK, this context, we don't know the type, but here's your explicit type. OK, so now we can run a few tests to see if this thing works. So here we have the console log. And assuming that we have the throttle, when we first initiate A, it should print A, and then BC should be cancelled. So let's try to execute this. So see, the A is printed, and BC is cancelled because the cooling period hasn't passed. And then we can also execute tests. And all tests pass. So this means we solved the problem correctly. All right, so congratulations on solving another problem. Do we have any question on this one before we jump to the next?
I have, so it seems to me that this function argument that we have here, the type of the function, so f extends, blah, blah, blah.
Yep.
That seems to come up often enough that maybe there's a built-in TypeScript already for that, a thing that...
Oh, you mean like this thing?
Yeah.
I don't think there is, but you can create a utility type called any function and then just copy this.
Okay.
To cut the time. But I don't think there is a default type in TypeScript for that.
Because they have a lot of things like that in TypeScript.
Yep.
I'm not totally aware of, but okay, thanks.
Can this have type any?
Yeah, you can have type any, but the proper way to, like the correct way, or maybe orthodox way to say unknown, because when you type as unknown, you cannot assign anything to this variable anymore. But if you type any, this means that you can assign any to any other variable. So it's more like it's unknown provides more type safety in this case.
Could you call function with arguments or function args rather than fn to apply? Sorry, let me try that. Could you just call fn with args rather than fn to apply?
We can, but in this case, we'll lose the context. So when you execute the function like this, so it's executed without the context. What if you have an object, A, and then on this object you have the function? So when you execute A function, then this context will refer to this object. That's why we are providing this context to apply method to make sure that the context is preserved. Any other questions?
Could you talk a second about void versus any?
Unknown versus any. Okay.
Void versus any.
Oh, void versus any. So the void is essentially the type that it basically returns nothing, but any, it basically returns anything. So the main difference is like any can be anything, while void is just basically empty. So that's the utility type that TypeScript uses for the function. It just means that the function doesn't return any value. If you provide any as a return type, in this case, you expect it to return something. You just don't know the type of it. love that people asking questions about TypeScript. Okay, should we jump to the next one? Okay, next one is called ES5 extends. So we're going to build extends function, but in ES5 style. So the idea here is that you have two constructor functions, supertype and the subtype, and we're going to mimic the prototype-based inheritance and combine these two constructors to build a function that kind of extends both of this. So, and the idea here is to test your knowledge about the prototypal inheritance and how the actually ES6 inheritance works. Although it's not fully replicating the ES6 behavior, but it just it also gives you the understanding how it can be established using the ES5 syntax. The idea here is that we need to execute both supertype and subtype constructors to get all the fields from both constructors. And also we want to copy all the static methods available on the supertype. The static methods, it's when you basically have the function subtype and you directly define function on the subtype instead of the prototype. So, and here how it could work. So you have the dog and you have an animal. So the animal have a few methods like eat and sleep, and then you have a few static methods on animal itself. So this is stored on the prototype, this is stored on the animal function. And then if you extend it, then you should be able to call both eat and sleep from animal, and you should have access to the static methods. And before we dive into the coding, I want to explain how the prototype inheritance actually established. So imagine the situation. So we created the doc instance through the doc constructor function. So now, how the doc instance is connected to the doc.prototype where you define all the methods. So this magic is called protofield. So essentially the protofield links to the doc.prototype. That's how we have access to all the doc.prototype methods. And every object in the JavaScript has the proto, which refers to the prototype of the object of the constructor function, basically of the function that was created this instance. And if we don't have any available methods on the doc prototype, then we need to establish the next link to the animal prototype. So if we try to access the proto of the doc prototype, then it should link us to the animal prototype. So we should be able to access any method on the animal prototype as well. And if we don't have this field or function on the animal prototype, the last resort is the object prototype. So in this case, everything will go to the object prototype. For the static fields, the static inheritance basically works that we just copy the fields from animal to the doc function, and we can establish this link by assigning the. And I know it will sound confusing, but we can set the doc prototype to the animal prototype, and it will be a different thing. And I'll show you in the code. Okay, so let's jump into the code, and I'll try to explain line by line what I'm doing. So open ES5 extends, and here you have the steps, what you need to do and what you need to create. So here we have two functions. So this is the only problem where we don't provide a proper typing because it's very hard to type in TypeScript. So we are using more wider type as a function. Okay, so first let's create our future type. Let's call it function extended type. So our extended type will be called with a new keyword, and what we need to do, we need to make sure that we execute supertype and the subtype constructors. And in order to do this, we need to have some target method, like the object on which will serve as a context and will accept all the fields that these two constructors will provide. So first we create a target, and then we use the default object.create, and we link the prototype of the target to the subtype prototype, because we want we're kind of mimicking the initiation of the through the new with the subtype function. So now we want to call both supertype and the subtype. So for this we call supertype.apply, and then we pass target as the context. So when we execute it, when we execute the supertype, all the fields that assigned to this context will be assigned to the target element. So, and also because our function should accept the arguments, we pass it like this. Args. So the supertype constructor is called, and we're going to repeat the same line for the subtype. And then we're going to return our target object. And here we return the extended type. But we're not done yet. So what we've done right now is just we basically now setting all the fields on the target objects, but the prototype chain hasn't been established. So to establish this, we need to call our default method called setPrototypeOf, and then we link the subtype prototype to the supertype prototype. So essentially, when you try to use the target.some field, it will first look into this subtype prototype, because here we created this object with the subtype prototype. And then if no field present on this prototype, it will go to the supertype prototype, because we established the link. So now how can we link the static variables? So here we just link the prototypes directly. So in order to be able to execute the static methods, and they're executed like this, so we use the extended type and then some static. So apparently, the extended type as well has the proto field. So if you try to do this, extended type dot proto, so this will link you to the prototype. But we can change by default the prototype will be the function, but we can change this. So what we can do, we can say that the prototype of the extended type will be my supertype. And when we try to access any variable on extended type, we will also check the supertype because we set it as a prototype. And then we return our extended type. And I know it's super confusing, and it will take a few attempts and draw the schema to understand the full flow here. And if we try to test this thing, so here we're creating, so we have the two classes, animal with the name, and then we have the dog, which can bark, and have the breed. And then we're building our new constructor function, so the dog extends the animal. So if we try to output, use both methods, the greet and bark, so we should be able to execute it, as well as now the dog should also be instance of animal. So if we try to run this and see the result, you see that we can use both methods, the greet and the bark, and also the instance of gives us true. This means that we solved the problem and our extension works. And let's just as a final check run the tests. And all our tests pass as well. So that's the ES5 extends. And I expect that there will be some questions now. Yep.
Why do we do object.setPrototype of extended type, comma, supertype instead of object.setPrototype of extended type, comma, subtype?
Could you repeat it again? Sorry.
Basically, the extended type, supertype versus extended type, subtype.
Oh, you're saying why we're not doing this? Like this. That's because here we link the prototype to the subtype, but if we link the extended type prototype to the supertype, we will not have the access to the subtype.
I think it's the reverse. It's the second argument, supertype, being supertype instead of subtype.
Oh, okay. One sec. So here, what we're
On
saying.
step 3, sorry, not step 2.
Step 3, this one.
Yeah. So they're saying why not extended type, comma, subtype.
Like this. Extended.
No, for the second argument.
For the second argument.
Yeah, so
Oh, I know. So because in the problem, we're saying that we need to inherit the statics from the supertype, not from the subtype. So, and if we just provide the subtype here, then we will not inherit the statics from the supertype. Am I answering this right?
yeah, I think that's correct. Any other clarifying questions?
Okay.
A few people saying, this is supposed to be easy. A lot of folks like getting tripped up on either basic JavaScript or basic TypeScript. So we're going to have to go hard on telling them the prerequisites are learning JavaScript deeply and learning TypeScript deeply.
But to be fair, right now in the current environment, these questions are considered as easy. And it's still, so the whole workshop is designed to be slightly more complex than what you would expect on an interview. So if you will be able to understand this, then it will be much easier for you on the interview.
Is this the equivalent of the extend keyword in classes?
It's not full equivalent, but we try to mimic the behavior, yes. So it's very hard to mimic the behavior because there are some language-specific things that that basically we do inside the engine to make sure that the inheritance works. Here we're just trying to slightly mimic this behavior.
And I'm just going to echo what Dia says. For the mental model of JavaScript, go to JavaScript, the hard parts, and for the mechanics of JavaScript, go to Deep JavaScript Foundations with Kyle Simpson.
Oh yeah, I love these courses.
And then obviously TypeScript's Mike North has a ton of content on TypeScript with as deep as you want to go there in the TypeScript learning path. So.
We're going to take a quick
Yep, we'll take a 5-minute breather here.
and learn TypeScript.
Need to convert the tuple array that we have to the union type, and the union type is basically that the type R can be 1, 2, 3, 4, 5, 6, or true. And let's now dive into the next challenge. So open the folder 07 tuple to union, and you will see it's the placeholder type is here. So first of all, it's the same approach here. First, we need to define a generic and say that our generic should extend read-only any array. And then I'll teach you one more TypeScript trick. So here, because we know exactly that there are 3 elements, and the elements in this array could be only 1, 2, 3, 4, 5, 6, and true. So this knows that allows us to know that these are the only types that we have in the array because it's a read-only array. So, and if you remember, we can reference any array by using the index. So, for instance, if you have type A equals to 1, 2, 3, so you can reference your type as, for instance, A0. This will give you the type of the first element. So if we check, now it's not visible here, but it is 0. It is 1 actually, so it should output 1. What if we say that, okay, so now we know that you can only refer to this array as index through the index 0, 1, and 2, because there are only 3 elements. So we can basically say that a number, so we can basically say that if you refer to this array with a number index, then the value that we can receive is only 1, 2, 3. That's it. So, and that's the TypeScript trick. So, and if here we say t dot brackets number, so our test cases passes. Because TypeScript knows exactly that there are only 3 elements, and if you refer with any index, you can only get these 3 elements. That's how we get the union. So it basically converts this thing into the union that is provided here. That's our TypeScript challenge. Any questions on this one? Okay, so let's jump to the next one. So the next one is called pick. So we basically need to build a utility generic that is provided within the TypeScript already by default. So it accepts an object, and then the second generic it accepts is a union of the fields that we need to pick from the object. And the goal is so that this in this example, we're taking 2 fields, title and completed, and construct a new object. So this is actually a very useful generic that we use in a real-world scenario, but it's also good to understand how this generic is built. Okay, so let's jump to the code and open the pick challenge. So let's remove these generics for now to make it a bit more interesting. So the first generic that we're accepting is a type, and we know that it should be an object. So we basically saying that this type should be an object. And then the next generic is the keys that we want, the union of the keys that we want to get. So, and in order to improve our typing, we can limit this generic to be only the keys of T. And to do this, we can use the keyword called key of. And then we're basically saying that our key should extend any key of the T object. And now there is another concept in TypeScript called remapping. So we can remap the properties. So we can iterate over the keys. So this is we're iterating through the keyword called in the key. So the key is a union of the keys. And then because the key is the key of the object, then we can just use T like that, accessing the value. That's how we construct the object through from the union. And all our test cases passes, and yeah, that's it for the MyPick challenge. So, do we have any questions on the challenges? The next one will be more complex. The next problem is actually more complex.
Why are we not using read-only here?
why we're not using read-only, because here, why would you need to use the read-only? Because the original type is not read-only. So if the read-only only makes an object read-only, so it means that you will not be able to override the properties. But our goal here is just to reconstruct the fields.
What is P again?
Okay, so here imagine it's like a loop. So this basically converts for a property in key. And key is basically an array of the keys. And then we're iterating over the keys inside the object and remapping it to the values. So the P is just a single key, and key is an array of keys. But it's a union. But you can treat it, you can kind of build a mental model that it acts like a loop. Okay. So from now, things will start to get a bit more interesting. So our next problem called deep equals. So we'll need to build a function that compares two values. And even if it's a deeply nested object, we also need to be able to compare these deeply nested objects and arrays. So we should support primitives. And one edge case that many people fail to implement is the circular references. And I'll explain how the circular references work on the next slide. Okay, so imagine that you have two objects that have the same structure. So const A with name Alice, and then you create another field called self, and you basically create a circular reference. So the self will reference to the same instance of the object. And now you want to compare both of these objects. What will happen? So first you compare the field Alice, which is true, so this field is equal. And then you try to compare the self. So, and here you enter the recursion cycle, and where you try to compare the same object. So you are again comparing the name, so which is equal, and then you again compare the self. And then you enter the infinite loop. And at the end, you will get the range error and stack overflow once you reach the stack limit in your browser. How can we handle this? So in order to handle this, we need to remember the pair of the arguments that we already processed. So for this, we can create a cache, which will store, where we can, as a key, we can store the first argument, A, and as a value, the second argument, B. So if we already processed this pair, this means that there is a loop, and we need to return true. And if we haven't processed this pair, this means that it's not a loop, and we just continue the processing. And in terms of the input and outputs, we have two values. It can be any type, primitive or not, and the output is the Boolean. And the approach that we're going to take, so first of all, we're going to compare, strictly compare two objects and see if they're equal. So if it's true, then we return true. Then we're going to use the type check. So we're going to compare the types of these two objects. If the types are equal, this means that we can proceed to the comparing the keys. If types are not equal, then we return false. And then we enter the recursion. So if the type is array or object, then we also need to compare every key and every value. So we compare the length of the objects. If the lengths are different, then we don't need to compare the values because the objects are structurally different. And then if the keys are the same, we compare the values. And for the cycle detection, we're going to use a simple map or weak map to track visited pairs. If it's clear, we can go and code this. So open the deep equals problem, and this is the folder 09 deep equals. And here we already have the placeholder where we accept a few values and ignore the cache for now. And C, we have an imported function called detect type. So this is actually like 5-line solution that we already implemented, and and we can implement it here, but let's just save a little bit of time and reuse the detect type function. So just remember that this function is very useful across many problems, so we're gonna use it multiple times. So our first base case scenario, if two objects are strictly equal, then we need to return true. Okay, so what's the next step? Now we need to get the types of the object. So we can use the type A and then type B, and then use the detect type A, detect type B. So if the types are not equal, then we can return false. All right. Okay, next step. So now we know that the types are exactly the same. So the next case is the type is primitive or is it an object? And for this scenario, we can use the typeof, because typeof returns an object for every object-like value. So let's use this. So if typeof A equals to object, then this means that both values are objects. So actually, we not equals to object in this case. And now we know that the values are primitive, so we can use the normal comparison. A strictly equals to B. So now we know that A and B are the objects, so we need to compare the keys and the values inside. So first, let's get the keys of this object. So we can use keys A and keys B, and then we can use object keys to get the keys. But one thing I want to do here also is to initialize the set. So put the keys into the set, and I'll explain in a bit why it is useful here. So now we need to compare the keys, if the keys are the same or the length is not the same, and so on. So in order to cut the time for yourself on the interview, you can use the default standard method available on the set. So if you use this method is called symmetric difference. So we can ask the JavaScript to tell how many keys are different between these sets. So the symmetric difference returns the new set within all the keys that are different between these two sets. And if the size of this set is more than 0, this means that objects are structurally different. So we return false. Okay. Now we know that the keys are exactly the same, so we can proceed to the comparison. So let's loop through all the keys and values. So we can use for const key of keys A. So it doesn't matter which set we use because the keys are the same. And now we need to compare the values using these keys. So we use deep equals recursively, and then we access A key and B key. And if this comparison fails, then we return false. And otherwise, we return true at the end. So this should actually handle most of the cases now, except the circular reference. And to check this, we can uncomment this thing and see if the expected output is provided. So let's run it. Run. So as you can see, so the first value true, true, and this one where we compare null and defined, false, which is correct, and then we try and compare arrays and objects, and this is true, true, and the last one is we comparing two different objects, and it returns false. So now let's try to see if the circular reference works. So, and the spoiler, it will not work. So if we try to execute the test case that we reviewed previously, you see that, yeah, it's stuck. Here we go, maximum call stack size exceeded. So let's mitigate this. As we discussed, we have the cache where we can store the pair that we already visited. So here we can check if the cache has A, so the A was already processed, and the cache get A equals to B. So this means that this pair was already processed, and we need to return true. And we also need to add the values in this cache. So here, we can add the value. Once we understood that the objects are the same structurally, and it's the values that we are comparing is our objects, we can set AB, and then pass this cache into the next recursion call. And if we try to execute this method now, you see that it passes. So the circle reference, in this case, is valid. And the last check call is the deep equals. Let's execute deep equals tests and call run. And all tests are now passing. So congratulations, we solved the first medium problem. Any questions regarding the solution? Comments?
What part of the code checks array values?
Checks arrays values. It's here. One sec. We go through the keys because array is also an object, but the key is just a number. So we can use the keys to compare the values of the array as well. So this branch handles both objects and arrays.
What does it mean a.self equals a?
A.self equals a. So you essentially establish a.self will equal to the same object reference. So if we go back to the slides, so imagine this. So this is your object A. You set up the name .alice, and then you're basically creating a new variable that is assigned, and you assign the A, the same object as a reference. So it's basically infinite object which reference itself.
Could you please, Could you please walk through how the cache portion prevents infinite recursion?
Okay, so here we store the pair A and B. So now we know that we process the A and the B. And here at the start, we're checking if A and B were processed. So we check, we get the key using the A, and if the cache get A equals to B, this means that this pair was already processed, and it's the infinite loop.
Quick question.
Yep.
Why do you need to check only if cache has A and not the case when cache has A or cache has B? Why are you just checking on A on that particular part, not on B?
Why I'm checking cache has A and cache get A, right?
I know. So the question is, why you don't need to also check if cache has B?
Oh, it's because we are storing the pair where the key is the A and the value is the B.
Ah, okay.
Yep.
What if we have two objects nested that have the same key, so like name in both a
Yeah.
higher level object and then a nested object.
Should be equal to true. We have this test case here. A1, B2, B2, B1. And if we execute this, we get true. They're the same.
So it checks that it's referenced to that particular object.
This test case, or which one?
I'll bring you my computer just so you can see the question.
Mm-hmm.
So essentially it's saying there's an object with name value here and then
Yeah.
nested name and city. We've
Okay.
already been through the key name. How does it check that name is referenced to this object instead of name is referenced to
Oh, okay. So in the code
so
here.
maybe re-ask the question.
So
Or repeat the question yourself and then answer it.
I got the question. So the question here is this one. So what if we have the nested object like this? Name 1, and then there is another object. Like this. How do we make sure that we are comparing this name and this name? And so imagine that you have two examples. So example 1 and example 2. So on the first one, you're going to compare the name 1 and the name field of the example 1 and example 2 objects. But here later in the loop, we know that this is an object, so we have the key city. And we run the same deep equals with two objects, city and city. So here in the loop. So we're accessing the object by the key. So that's how we comparing both of these objects. Hope it's clear.
There's another one, sorry.
Yep.
I should read it because from Vicky D.
This two, please, curious. Is this basically? Okay, got it. And the comment is correct. So we are not handling the nan values here because yeah, that's the miscase. So ideally, if you're using some invalid values like nan, you need to use the object is to make sure that you're not comparing them. So, but in our exercise, we excluded some edge cases like this.
Could Evgenii close the run output when not needed so the code is more visible, please?
Oh yeah, sorry about that. Okay, should we run to the next one?
Yep.
So the next problem is called deep clone. So it's essentially same kind of the problems, but now we need to clone the value deeply. So the value can be anything. So it can be an object, an array. We also need to support special types, map, set, and date. And also we need to handle the circular references. And the primitives we just copy as it is. And it's the same type of the problems where you need to handle the self-reference And the way we're going to handle this is basically the same. We're going to have the cache, and first we're going to check if is it an object that we're cloning. If yes, is it already inside the cache? So if it's inside the cache, this means that we can just return it from the cache because it's already cloned. And if not, then we create a new cache variable and continue cloning the object. If it's not the object, we just basically use the value because the primitives, they are copied by the value, and then we repeat the process. That's the logic behind the deep clone. And open the next challenge called deep clone, which is the folder 10. And here you already see that we have some scaffolding set up to save a little bit of time. So first of all, let's go through the code. The first type you have is T collection, which is just basically a union of the collections that we expect. And also we have some utility methods that I'll explain later why we need them. Okay, so let's start implementing the problem. So we have the variable called a, which we want to clone, and our goal is to create a deep clone. So let's first detect the type. What is the type we're trying to clone? So and now here we use the detect type to get the type string. And if the type, for instance, if we're trying to clone undefined, or the type is not an object, so which means that it's a primitive, we just return a value because it's enough to clone the primitive. So now inside now we have the switch case between the type that we support in terms of the cloning, and we can provide a specific logic for every type. So for instance, with the date, it's quite simple. So we're just returning a new date, and then we pass a as date. And here the TypeScript will complain that it cannot cast the a. So first we cast to unknown, and then we cast to date. Okay, so. And also because here we are saying that we are returning the same type as we are passing, we need to cast it to the T. Okay, the next type is the object, map, set, and array. So we should treat these objects as the collection of key and values. So because these are more like a complex objects, what if we just could go for, so for instance, what if we could get the target object that we want to insert property into through the function called getTarget, and when we pass the type that we want to initiate. So this will give us a collection that we're trying to handle, and then we want to loop through the collection of elements and copy each element. So ideally what we want to implement is we're going to loop through the key and value of entries. So right now the entries doesn't exist. That's just a pseudocode I'm writing. And if we want to extract all the entries of our target object we're trying to clone, and then we want to assign each variable to the target object we created. So we use this magic set, which is also pseudocode right now. We pass our target, and then we pass our key and the value.
Okay, that makes sense.
And then we return the target as T. And now we have TypeScript complaining a little. Let's fix this. I think we're missing some brackets somewhere, and I don't see there. Okay. Does anyone see where we're missing the bracket?
No.
Okay, now it's gone. Okay. Now let's try to build this get target and entries. This pattern is called adapter. So we're basically adapting. So we're basically taking 4 types, and then we build adapter function that takes 4 different types and then handle them in a similar way. So first, let's implement the get target. So get target, here we already have the placeholder for this. So we can switch over the type, and then based on the type, for instance, if it's the map, we're going to return a new map. If it's the set, we're going to return a new set. If it's array, we're returning array. And if it's object, we just create an object. That's how we initiate the target. And in case if the type is not, if we're trying to refer to some unknown type, then we just throw an error. And that's it. Now we implemented the get target method. So the next step is to have the way to iterate or extract the entries, basically return iterable. So let's do this. Let's also switch over. So because now we're receiving the target as a union of collection, we need to use the instance of to get the specific type. So we use target instance of. For instance, if it's map, then we return target entries. Else if target instance of. Set, then we can use target entries as well, so we can merge this condition as here, like this. Okay, and maybe we could do the same with array. Let's check. I'm not fully sure. Target instance of array. Oh yeah, so array also have the entries method. Otherwise, because we know that now we handled all the cases and the last case is an object, we can just use the object entries. Entries and then the target. And now we have the function that provides a unified iterable object across all the types. And let's do the same as a set. How do we set the values? We're going to have the same instance of check. So we're going to check first target instance of map. If this is the case, we just use target set key value. And if target instance of set, then we're going to use the target at value. So the last check is the array and the object. So if else if target instance of array, we just do target key, and then we cast it as a number and assign the value. So here it should be equals. And now we do the last case, which is an object, and it's going to be the same as the array, and we're just making TypeScript happy here because if we don't handle it like that, then the TypeScript will not allow us to use the key because it could be a string, and the array requires the key to be a number. Okay, so now we set up all the things, and I think we can remove the escalation cost because it already does that. And let's see why it's complaining. Okay, it's because we're trying to declare the variable inside the case. Let's wrap it into the lexical block. Okay, so now everything should almost work. The last case that we're not handling is the cache. So what if we already cloned this value and now we're referencing the same value? So here the logic is basically the same. We need to check if cache no, actually it's not, it shouldn't be here. So if cache has A, this means that we already processed that. So we can use cache get A to get the cached stringified value. Now we want to set this value. Once we clone the target, what we do, we set the cache. So we're basically saying A equals to target. So now we are storing for the A variable, we're storing the clone target. And every time we try to copy A again, we just basically return the same, the value from the cache. Okay, so let's try to execute a few tests. So here we have a few examples. Let's run it. So the idea here of this test is, and it doesn't work actually. So the idea here is the first AB should be unaffected because we cloned this value, and the cloned AB should be 99 because we modified the cloned object. Let's see why it doesn't work. So here we detect the type. Here we return the target and the key values of entries A. And then, okay, the reason why we have this error is because if the object has a nested objects, we also need to clone the object deeply. So in this case, we also need to wrap the value into the deep clone, like this, and then pass the cache inside. And now if we try to run it, you see now both cases work. So let's run a few more. For instance, this one. So here we're cloning the map. So and the test case passes. And here, let's try to clone the circle reference. And it should not fail with the recursion stack. And it fails with recursion. Let's see where we are failing here. So, okay, so it fails with the recursion because we're setting the cache only after we calling the recursion. So this is incorrect. So we should set the target before we enter the new deep clone call. So if we try to execute it again, see, now it's passing. And as the last step, we also want to check all the tests, and all test passes. Congratulations, we learned a bit about the adapters and how to kind of make the code logic simple. So we could duplicate the logic for each case, but instead we built two adapter functions, and then we treat all the collections the same way. Yep, questions?
In the cache, we use the object reference as the key.
Yep.
So we have an sort of a, like you said, it's the adapter pattern, right? Or
Yeah.
is it, right? If you were grading this as an interviewer and somebody did this versus coding each of those cases individually, is there a bonus or a negative for coding them individually versus?
Not really, because on interview, you will not always know, can remember all the patterns, and usually you're stressed and you're trying to solve the problem. As long as the logic is correct, I wouldn't penalize the candidate. But if the candidate brings this pattern, I would say it's a good bonus point because I could see that the candidate applied some good patterns inside the code. Good. So let's jump to the next TypeScript challenge. So here we need to implement the TypeScript generic type called read-only. So what it takes the object as the input and then makes it read-only on the type level. And yeah, that's about it. So let's open the IDE again with our read-only challenge. And here we need to build this. So again, let's type our type called my read-only, and then we define our generic. So our generic should be an object, and in order to tell TypeScript that, we need to use the word extends, and then we use the object to say that the input should be an object. Okay, how can we make the every field read-only? So for this, we need to remap our input object, and in order to remap this, we need to iterate over all the keys available inside the T. And in order to do this, we need to use the in loop with combination of the key of. So for this, we say property in key of T. So this thing will basically does nothing. So it will take an object and remap all the fields to the same values. So we not add any special property here. So, but we want to override the read-only property for each field. For that, we just need to add the magic keyword called read-only, and now all our output object will be constructed as a read-only. That's the logic behind the my read-only type. So as you can see, most of the utility TypeScript types, they're built actually with the language. There is no magic around this.
We're not doing a recursive. So if the object, if the type has a field that's an object.
Yeah, it's not recursive right now, so we'll have the recursive challenge later in the course.
Okay.
I just don't want to spook all the people with recursive types for now. Okay, so the next challenge is called tuple to object. So essentially, we have our favorite read-only tuple array, where we have the four items. And what we want to do, we want to iterate over this array and convert this to the object. So essentially, the key and the value will be the same. So the tuple will be converted to the following object in the example. So key is basically the value. And how can we do this? Let's jump to the next challenge, which is 12 tuple to object. And here we already limited our generic to be read-only any array. So, and now we want to loop over possible keys. And remember, we learned the trick. So if I access the T number, then essentially it will provide me with all the union types that we have. So it will convert to the union. And our magic keyword, which is in TypeScript, so we can say key in some union. So it iterates over the union. So what we can do here, we can extract the union, by accessing our type and providing the number. So that's what we learned from the last trick. So which now converting the array to the union, then iterate over over every union member, and then we basically assign the value which will equal to the key. And let's see why it's complaining right now. Oh, it's actually not complaining, sorry. So all the tests are passing now. So we are converting our tuple into the object of this structure. Any questions? And just to demonstrate how it works, here what the TypeScript will see. So if we have some array of the union, so this is basically how it would work in the inside. So we iterate on each union member, and then we set the value. Any questions on this challenge? Okay. All right, so the next problem, which is the medium one, is the stringify. So we're going to implement the JSON.stringify, and we'll handle the circular reference support. And that's another like DFS style problem with the same approach where we need to introduce the cache and handle the circular reference. Here's the requirements. So the null will be converted to stringified null. So all the numbers will be just wrapped in the will be stringified. Same for booleans. The strings should be wrapped into the backsticks. So big integers should also be just stringified, and so on. So we have all the spreadsheet inside the skeleton file as well. And the logic for this is almost absolutely the same. So first, we check if the object that we're trying to stringify is not a primitive. So if it's not a primitive, then we iterate on each value of the object and stringify it. And if it's primitive, then we have the switch statement that will stringify each field based on the logic we're providing. That's the overall approach. How can we solve this problem? Okay, so let's jump to the next coding exercise, which is stringify 13. And now we have our scaffolding here. We already have a switch with all possible types that we can handle. And we have our spreadsheet, kind of the cheat sheet that we can use to understand how we are handling all the types. So this problem will be much easier, but it's a bit annoying because you need to type all the cases. So it's not particularly complex, but it's also good to know how to solve it properly. Okay, so from the cheat sheet here, we can see that these 4 types are mostly handled the same way. So we're just basically stringifying them, and we just basically convert it to the string. So we could technically treat it here already. So just return a stringified value. Okay, so now we have 4 types already handled. So now we have the symbol and undefined and the hello. So here we are basically wrapping the whole thing into the backsticks. Yeah, we can also handle it the same way. So just by doing this, use the backsticks and then use the template string and then convert the value to the string like this. The next, before we handle the objects here, let's handle the rest of the more simple cases, the date and regular expression and the circular reference. So for the regular expression, we're gonna convert a to the regular expression and then just use toString. So nothing complex as well. And for the date, we're going to convert the object to the date, and then call to local string as specified inside our requirements. So here we are saying that we need to call the to local string. Okay, the remaining parts are the complex objects, and let's handle them. So I would assume that object and map should be handled the same way because it's just a key value storage, and when we stringify it into the JSON, it should be just an object. So for that, first, before we start converting, we need to get the entries of the object. So let's do this. Let's create a variable called entries. And then if the A instance of map, then we call A entries, which is default function available on the map. Otherwise, we just call object entries. That's it. Now we have our entries. And essentially what we need to return is this. So this is the object that we're opening here, and then we need to return the content inside, like this. So let's now try to build this content. So let's create a variable content. And now we're going to map our entries. So we'll create an array from them because entries doesn't have the map method. And then we're going to map the values. So the entry will contain the key and the value. And now we need to return a string where we have our key. And then we need to stringify our future value because the value can be an object as well. To convert the whole thing into the string, we want to join the references and do it like this. All right, and let's see. The TypeScript is complaining because stringify doesn't have the specific method return type. So let's make sure that it returns the string. So now we have the object stringified, and we can do the same thing for the array and the set as well. And it will be much easier for the array. Essentially, what we need to return is this: an array with some content inside. So let's create a variable content again and convert the incoming array or set into the array, because set can be converted to array as well. Is it terrible? And then we just gonna map the value, and because it's just an array, we can just stringify the value. And same logic here, we want to join the array to convert it into the string. And we are joining entries with just comma. And then we pass the content. And the last remaining bit is the cache. What if we already processed what if we have the circular reference and the exercise requirement saying that if we already processed this reference, then we just need to return a circular. So in this case, what we need to check is if the cache already has A, then we just return the circular. And now we need to add the variables to the cache. So here inside the map, we just basically add the variable that we're processing, which is A, and inside the set array case as well. And also we need to pass the cache inside the recursive call for both cases. Okay, and I think it will work. So let's try to test a few examples. Run, and see all the values are now stringified. The string is wrapped into the backsticks. And let's also execute a few more cases with the circular reference as well. And then let's run. Now the circular reference is handled as a circular, which is correct. So the regular expression is using toString, and now we're converting to the local date. Now we can run the tests. I think they will fail because there is some, the tests are spacing sensitive, and we can fix it easily. 1 second. No, they're actually all passing. So, yep, that's the stringify problem. Do we have any questions on the stringify? And I would like to make a break after the stringify if it's possible. Because we're going to handle a very complex problem next.
Oh, you want to take a break?
Yeah, just 5 minutes.
Okay. Break.
Hey everyone, welcome back. So I hope you had a nice break and we can continue. So our next problem is the first hard problem, and you will see why. So the goal here is to implement the promise. So basically we're going to implement the most of the functionality of the promise itself. So this means that we'll need to handle then and catch, chaining, static resolve and reject, and also we'll need to handle free states, which is the pending, fulfilled, and rejected. And also we need to make sure that the callbacks that we're running executed in the microtask queue. As you know, there are two types of the asynchronous queue that we have in JavaScript. The first one is the timeout queue. The second one is microtask queue. So the promises are executed within the microtask queue. And the promise itself, before we jump into the code, I want you to have a high-level understanding of how the promise works. So first of all, all the promises start with the one state called pending. So when you create a promise, default state is pending, and then it can be resolved in two ways, fulfilled or rejected. And then we also have the handlers that we queue and execute later. So what happens when you call new promise to executor? So first of all, you pass the executor function. And executor function is the synchronous function or the process that you want to execute within the promise. So it can be a synchronous call to the server or some synchronous function with some logic. And executor function itself is basically a user process. That's what you define. And while the process is being executed and awaited, you can register two types of the handlers. So there is a success handler, which is then handler, and the catch handler, which handles the exception situation. In order to execute the then or catch handlers, we need to resolve the promise. So there is a promise. So this is also called promise settlement. So in order to settle the promise, you need to call either resolve or reject function within your executor function. So, and reject will change the status of the promise to rejected, and resolve will change the status to fulfilled. And this is basically called promise settling. And once we settle the promise, now we can execute our then or catch handlers. So, and we call our handlers later. So that's the high level of things, but as we start implementing this, it will go a folder called 14 promise, and then you have the scaffolding around with all the steps. So first of all, we already have a defined type called type promise, promise status, and it can have three statuses as we discussed, and then we created a constants for each status to use within the code. So now let's first properly type our promise. In order to type it, we need a few things. First of all, it's our executor function. It's what we execute inside. Let's first type this in. Let me quickly create a type called executor. And then it will have a generic T, basically what's the type we're handling in the resolve and reject. And then executor function, which promise accepts in the constructor, is essentially the synchronous function with two arguments. The first one is the resolve. And resolve can take the value of type T, and the value can also be the promise. So here we're linking, so we're saying it's either type T or promise. Here we can go promise like T. All right, and the resolve function returns void. The next thing is the reject function. So the reject function takes the reason, basically why we failed, and it can be of type any, because we don't know exactly what's the error will be. So that's why we cannot type it. And then it returns also any, because we cannot really detect the type of what it's returning in the reject. Okay, so this is the first step. Now we can type our executor function in the constructor. So let's place the T as the generic on the promise, and then we can pass the T executor inside T like that. So this is the first step. Now we have executor properly typed. The next thing is unfulfilled and unrejected callbacks. That's what we pass inside then and catch. So let's also type it as well. So I'll create a type called onFulfilled, and it will accept two generic parameters. The first one is the type that we're handling right now, and return type, because when we do the then, so we are able to transform our type into another type. That's why we need to have the second generic here. And then the unfulfilled itself the callback itself can be null. It can also be undefined. And if it's defined, then it can be the function. It is a function that accepts the value and returns R. One sec. TypeScript is complaining. Probably because we need to wrap it like that. Okay. So also we can pass, instead of T, we can also pass the promise like value. Promise like T. All right, so now let's copy this over, and we need to define onRejected function. So onRejected function will have just one generic, because we don't know the type of the incoming value when the promise fails. So this means that the value, the reason can be any, and the values are. Okay, so now we have our onFulfilled and onRejected callbacks, and now we can use them to properly type the then and catch. So our then accepts the onFulfilled callback of T and R, and onRejected. Oh, actually, sorry, I missed the type here. So onFulfilled T R and then on rejected of on rejected R. So one thing to note here, we don't have the R type. How can we get this? So because the R type is defined by the user, so by the developer, by basically the user of the promise, so this means that we need to ask TypeScript to infer this type. So that's why we provide the generic value R. And by default, we could assume that the return type will be the same as t, but if the user provides its own type, then it will be automatically inferred. That's how we type the then function. Same process for the catch. So catch accepts on rejected callback. And also, we ask here we specify the R generic to tell TypeScript to automatically infer the return type from the function that the user is passing. Okay, and
with the unrejected, would it be better to set the type the value as unknown and then narrow it down inside on the error?
Yes and no, because you will not be able to assign unknown to anything, and in the future we'll need to assign the new value. So if it's unknown, then it's impossible on the type system level. So that's why we assign it to any. Okay, and also one thing to note is on rejected field should be optional. So we can just pass one function. So in order to implement the catch, it's actually very simple. We can just call then, and then pass null as the first argument, and then on rejected. So the logic will be the same. That's it. And now we properly typed on fulfilled and on rejected, and the next step is to create a type for the handlers that we store in the promise. So every time we register the handlers, we need to push it to the state in order to execute later. So what's the type of the handler we'll have? So let's define the T handler, and the handler will contain two possible callbacks. The first one is unfulfilled, in case the promise is fulfilled. And here, what we're gonna do is to define unfulfilled callback in a more in an easier format. So it is any value of void, and I'll explain why we're doing this. And on rejected, so here I'm typing this as any value in order to avoid handling the types within internal logic. So because if we provide a specific type, then we'll have to do lots of casting, and because we do not expose this API to external developers, it doesn't really matter how we handle these types. So for this, just for making our implementation easier. And the remaining two fields will be resolved. It's basically the function with the link to the function of the promise with which we need to resolve the current promise. And I have a slides explaining how it works. Just in bear with me. So the resolve will accept the value and will return void. Oh, yes. And the reject will accept the reason and return void. Okay, so this is our T handler. And now let's create the variables on the promise itself that we need to use in the future. So first of all, each promise have the value, and the value by default is equal to null. So when we create a promise, because we don't have any value yet. And then we have the field called status. So the status is essentially the promise status. And by default, it's always initialized to pending. The next thing to have is the handlers that we need to execute once the promise is resolved. So this will be our tHandler array. And by default, it's just empty. Okay. The next thing, we need to understand if the promise was resolved. So we'll create a Boolean flag called isResolved. Boolean equals to false. All right, so now we defined all our fields. Let's now understand how the promise can be settled. So I'm going back to the slides to explain this. Okay, so the promise can be settled using two functions. The first one is resolve, and the second one is reject. So we can only settle the promise once. Once the promise is settled, it cannot be unsettled. So if we try to recall resolve or reject twice, we need to just basically return and do nothing. And if it's not settled, and the value that we're trying to settle the promise with is promise, then we need to wait for the promise and then update the status and the value, and then run all the handlers. I know it's a bit confusing, but when you're trying to resolve the promise with the promise, the way the JavaScript works, it awaits the promise that you're passing as a value, and then updates the value of the promise. So we basically need to replicate this logic here. So let's now jump to the code and I'll go as slowly as possible, explaining each line, and hopefully you'll be able to understand. So now we need to define two functions. One is called resolve, which takes the value or the promise of this value, of the value. And then it do something. And then we also have the reject function, which also takes the reason why the promise failed of any type, and then it returns void. Sorry. So these are two functions that we need to call when we settle the promise. And here, let's pass these functions to our executor. So remember that the executor is just a synchronous function. So it's immediately executed once the promise constructor is called. So what we need to do, we need to wrap our executor in a try-catch block, because the executor function that we are passing can throw. So this means that we need to handle the error. And then we're just using the executor and calling it. That's the user process that we're calling. And then we pass our resolve and the reject inside. And then if the executor fails, we just calling the reject, and then we pass the exception inside. So right now it's a bit complaining. Let's see why it's complaining. Oh yeah, it's because I used the promise type, but we're not using the promise. It's promise-like. So the TypeScript has the utility type called promise-like. Essentially, the promise-like, it's anything which have the then method. It's called thenable. So that's why we use the kind of the interface promise-like that for our custom promise. Okay, so now we're calling our executor. And once the user process is completed, the user process will call the resolve or reject. So we need the way to settle the promise once it's called. So let's create a method also called settle. So I'm going to use the private function called settle. And we can settle the promise with the value that we're passing, and also with the some status. And by default, the status will be fulfilled. And I'll explain why we need a separate function for that. And the reason for separate function is because we can basically use this function here in both cases, in resolve and reject. So if the promise is resolving successfully, what we do, we just call this settle value. And here our settle should also handle the promise like t. And in case of reject, we also call the method settle with the rejected status, and then we pass the reason. So both resolve and reject now handled by the single method called settle. In order to settle the function, remember we had the, on the presentation I mentioned that the promise can only be resolved once. So we need to check if the promise was resolved. If the promise was resolved, then we just return. We don't do anything. If it's not the case, this means now that we're ready to resolve our promise, and we mark our promise as resolved. Okay, so now what happens next? Now we need to check if the value is the promise. So for this, we're going to run the following check: if the value instance of my promise and the this status equals to fulfilled, one second, let me check the logic again. Oh, wait a sec, sorry, this one, the promise is not yet, doesn't have any status yet. Okay, now we are checking if the value is the promise. So remember, if the value is the promise, then we need to await this. So let's call then. And then we need to call some method that will update the state. So for now, I'll just call it update. And here, we also do update value. So in both cases, we're going to update the state of the promise. So let's create a utility function called update. And then the update will take the, basically takes the value. And then it sets the value. So it sets this value equals to value. And now it also sets the status that we passed. Okay, and now, so here the TypeScript is complaining that we are trying to use the value with the type T. So we need to explicitly tell TypeScript that it's the type T. Okay, so now our promise can be resolved. So this is the first step of implementing the promise, and we're going to run a few tests to verify that our promise can be resolved. And remember I said that once we resolve the promise, we need to call our handlers. Right now we're not calling any of them, and we don't register any handlers. But in the future we're gonna run them. So let's create an empty method for now called execute. And in the future, it will take all the handlers and execute them. So for now, it doesn't do anything. So once we resolve, we just call execute. But for now, it's just empty function. Okay. Let's run a few examples to see if our method works. So right now, we have the promise that is resolving with a static value. And if we try to resolve it, so our method will be called, and the value 42 will be assigned to the promise. So if we try to run it, see, now the status is resolved, and the value is 42. So we successfully resolved our promise. Let's call another one. So let's try to reject the promise. Same thing, we are running the reject. Here we have the value error, so which is correct. And the status is rejected. Cool? And let's try to now settle the promise twice. So what if the user tries to call the resolve twice? So if we should have the value 1, so it shouldn't be resolved later with the value 2. So let's verify this. See, our value is 1, because the promise can only be resolved once. Okay, so this was the first step. And before we jump to the next step, are there any questions on the stream or within the room?
What is the pound sign in front of the settled for?
Could you repeat the question again?
What's the pound sign in front of the settled method for?
This one. It's the private method. So essentially, the private methods cannot be accessible outside. So ideally, we could also use resolve and reject should be also private. So we can keep it the same way. So
Is that just a shortcut for private?
no, it's actually different. So in TypeScript, when you do private, it's not actually private. You can still call it within the within JavaScript code. It's just for the type safety. That's it. So it's not real private method. But if you want a real private method, then you need to use this sign. And it's not a TypeScript feature, it's a JavaScript feature. So it makes the this function only callable within the object itself. Okay, is it all clear? All right, now bear with me. So I know it's not going to be super easy, but here on the high level schema, here we are. So right now we implemented the reject and resolve method. So we also started to reject and fulfill to make the promise status as reject and fulfilled, and then we settle the promise. So our user executor function executes the user process, and here is incorrect. We actually already implemented the constructor. So here the constructor is the user function that we are passing. Now we need to implement this part, then and catch. So right now our promise is just like settled. It doesn't call any then or catch handlers. So first we need to register these handlers and then call them within the execute method. So let's do this. But before we do this, let me explain how it's going to work, because the logic there is not super trivial. So imagine that you have the situation. So the promise, you're creating the promise A. And then you started to chain the promise. And remember, when you call then, you always create a new promise. So that's how the things in JavaScript work. And if the promise B calls another, if you chain the promise again, then you actually create another promise, which is promise C. And in this case, how do we resolve things? So first we resolve the promise A, then we resolve the promise B, and then we resolve the promise C. That's how the chaining works. But how do we implement this chaining? So here, how we gonna solve it? So first of all, here we try to call the then method a few times, and then once we call the then, we create a new promise. And promise B have its own resolve and reject within the executor function. So that's why we edit the fields called resolve and reject on the handler. So we're gonna store the resolve and reject of the promise B on the promise A. So when we resolve promise A, we can call handler h1 and resolve the promise B as well. So it's basically we're establishing the link between the promise A and promise B. And let me show you a few more examples how it's going to work. So imagine that, again, we have this chaining. We create the promise A, and then we put the handler inside, h1. The h1 handler will have the links, will store the reference of the resolve and reject of the promise B that was passed inside the constructor. Then once we execute h1, we will also call resolve and reject of the connected promise. This will allow us to resolve the promise B. The same way, we're going to resolve the promise C. That's how we're going to implement the then method. And before we jump into the code, any questions?
How does it work if there's only one promise? If there's not B and C, there's just promise A.
You mean like, 1 sec, let me go back. So this is the promise A right now. and we're passing the executor function, which just resolves. There is no then catching. So when you use then, the then always creates a new promise.
Oh, okay.
That's how the things in JavaScript work. So every catch or then will create a new promise. Okay, so let's jump into the code, and I hope it will be more clear once we code it. So I'm jumping to the then method here, and here we already receive our onFulfilled and onRejected callback. So now we need to store these callbacks. So let's create a handler called using our type called tHandler. And then let's assign the onFulfilled. And remember, onFulfilled can be null, so we don't want to deal with the nulls. That's why we're going to check if the onFulfilled is a function. So type of onFulfilled equals to function. Then we assign this onFulfilled. Otherwise, instead of assigning the null value, we'll just provide a stab function, which basically takes the value and returns the value. Nothing complex. And also onRejected can be null, so we do the same check. Type of onRejected equals to function. And if it's the function, then we basically assign the onRejected. Otherwise, we assign the default function which just throws. Because on catch, we always throw. So if few fields are missing, is resolve and reject. So for now, we assign resolve as empty function because we're going to assign the resolve and reject once we create a new promise. So this is just basically to make TypeScript happy for now. Okay? So now we have the rule. Every time we call then, we create a new promise. So let's create a new promise. So promise equals to new my promise. And now we have and my promise will return the error type, which we're declaring here. This is the return type. And the new my promise is taking the executor function, which have its own resolve and reject. And now we establish the link between the current promise and between the new promise. So we assign the handler resolve equals to resolve, and handler reject equals to reject. So when we fulfill the current promise, we'll be able to call the resolve and reject of the connected promise. So the connected promise will be also resolved in this case. And then we want to push the handlers inside. To call them later. And also one thing to note, you can call then and catch when the promise is already settled. In this case, we need to execute the callback immediately. So if this status not equals to pending, which means that the promise is settled, we immediately execute all the callbacks that we scheduled. And we return the promise. That's the implementation of the then. So for now, we're just registering the callback. The callback still is not executed because the execute function is empty. So let's now go to the execute function. So what the execute function does, it iterates over all the handlers and then execute them in the microtask queue. So let's do this. So first of all, we're going to loop through our handlers. So here I use the destructuring operator of these handlers. And in order to not forget to clean the handlers, I'll just do it right now. So after we executed all the handlers, we need to empty the queue. So now we're taking our unfulfilled, onRejected, resolve, and reject methods. And now we should be able to execute the loop. So first we need to establish which handler we want to execute, because the status can be either resolved or rejected. So if the status equals to fulfilled, then we call our unfulfilled function. Otherwise, it will be onRejected. That's our handler. And now we need to queue the microtask. And there is a default function that allows us to queue the microtask. It's called queueMicrotask. All right, so we wrap our handler execution in a try-catch block. And then now we try to execute the unfulfilled handler. So let's do this. We define const value equals to the handler this value. And remember that the handler itself can return the promise. So in this case, we need to verify that if the value instance of promise, oh, sorry, it should be my promise because we're using the custom class. Then we're going to wait for the value and pass the resolve or reject. Otherwise, we just resolve with the value. And excite exception, we do the reject.e. So if any exception happens, we just immediately reject. So that's the execution part. And any questions on execution part?
Can you explain a little bit more the queueMicrotask function? Like how exactly does it work?
Okay,
While we're
so
using it?
in JavaScript, in the API, we have the setTimeout. And this setTimeout just creates the callback inside the callback queue.
Yep.
The same way you can schedule the queueMicrotask. So what this thing does, it schedules the call inside the microtask queue available in the browser. That's how we delegate the call to the microtask queue.
Thank you.
Okay, so now I think we can run a few tests to see if everything works as expected. One thing I noticed that, okay, let's run the test. I think we have a mistake somewhere, but let's see. Okay, so let's also implement resolve and reject because this is the easiest part. Every time we resolve the value, we just create a new promise with a static value. So we just return new my promise. And then we call in resolve with the value that we're passing inside the static resolve method. And the same way for the reject. So we're creating a new promise, and then we reject it. So first resolve we're not using, we're using the reject, and here we're passing the reject. And here we need to declare the value, which is R. That's it. So now we have all the methods implemented. So let's try to verify if things work as expected. So first of all, let's run a quick example. Here on step 6, then and catch chaining. So when we resolve the value with 42, we should be able to see the chained then. The then will create a new promise, and then expected value is 42. So let's try this. Call run, and the value is 42. So the then handler is executed. So Same thing for example 6. So here we have the result first, then we create a new promise with v plus 1, and then we chain another promise with the console log. So this means that we should output 2 as a result. So let's run, and it's 2, which seems to be correct. Okay, and now let's try to reject the promise. We're rejecting the promise with the error, and then we try to catch this and console log the error. So we should see the error in the console log. Yep, and see the error is here in the console log. And also, let's try to see, because every time we create a new promise, the new promise has unsettled status. So if we try to recover the promise, so we catch the error and then call then, we should be able to see the console log value as well. So recovered. This means that the creation is successful. Okay, so now let's run the test and see if our solution is correct. I think it's almost correct. Oh, sorry, that's the wrong test. So let's run the test. Run. All tests pass. All right. This means that our promise solution is more or less in line. So before we jump into the new slides, are there any questions in the stream or in the room?
I'm a bit confused about why we create handlers as an array, but then use the object destructuring to execute them.
See, we iterate over the handlers, and this handlers is an array object that contains every handler. And one single handler is an object that contains the fields. So that's why, because each promise can have multiple handlers. That's why we use the array here. Okay. And let's reiterate how the handler is executed. So we pick the handler from the array of the handlers, then we schedule the microtask queue, then we executed the handler, and then if the value is promised, we wait for the settle and resolve the promise or reject it. And the handler execution is here, so it's basically the same logic. We're running over the handlers and execute them. So we just resolved also the statics. So here, what the static function does, it creates a new promise with the value that we provided, and the same for reject as well. So congratulations on solving the first problem. I think we have like 20 more like this. So yeah, I think this one was very challenging because I don't think like every engineer can solve it on the first attempt, on the especially on the interview. So, but this problem is hard. So it's actually, once you understand how to solve it, you can solve any problem related to the promise because you know all the internals and how things work. Okay, so let's jump to the next hard problem, which will be the last in the section. But before we do this, we have a few challenges to resolve. So the next TypeScript challenge called append to object. So what this challenge does, it creates the new field on the target object with the specified value. So it accepts the type that we need to append the value to. It accepts the key and the value. So let's try to solve it now. Let's open the append to object challenge. Folder 7, and create our type called append to object. So the first generic argument that we have is the object, so that's why we need to make a t_extends object. The next generic argument is the key that we want to add, and it should extend string, because the key should be a string, and then the value. And the value can be any. Okay. In order to append the new value to the object, what we need to do, first we want to iterate over existing keys. So in order to do this, let's loop through the keys in key of t, and then we just use t dot property. So this will basically reconstruct the existing object without adding anything. So how can we update the union here? The key of t gives us a union of the possible properties. So in order to update the union, so we can extend the union by providing the key like this. So now we're kind of updating the union and saying that, okay, iterate over all properties of this object and the key. But the thing is, the key is not a part of the object. That's why the TypeScript is complaining. So what we need to do now, we need to check if the property extends the key of the object, then we assign the value of the object. Otherwise, we assign our custom value. And all tests passing. Is it clear to everyone? All right, so let's jump to our next challenge, which is called merge. So we need to merge two types. So essentially the fields of the type bar will go inside into the type foo. So which means that the resulting type will be a number, b number, and c boolean. C that we have overridden the value b. The value b. The existing the previous type was string, and we used the type number to override it. Let's go again to the TypeScript to the new folder called merge challenge 8, and let's open it. Okay, so let's create a type called merge. And this type accepts two values. So t1, which should extend any object, and t2, which should also extend any object. Okay, so now we need to merge the unions between T1 and T2 so we can iterate over all keys. Let's do this. So if property in in order to merge the objects, we're going to use the merge operator, so T1 and T2. So this will give us the resulting object of T1 and T2. And then what we can check if property extends T2. So this means that it's a key of the T2. Then we assign the value T2k. That's how we prioritize the second object. The other case will be if property extends T1. Then we return, this. So this should be actually key of T. Then we return the value of the T1 object. And if it's not, which is kind of impossible case, then we just return never, which is an empty union. And all test case, just one. Actually, we have just one test case. It's passes, so we successfully merged the object. As you can see, the TypeScript challenges are also getting more complex. We'll soon face some recursive TypeScript challenges. Yeah. So, any questions? All right. So let's jump to the next problem, which is called tree select. Essentially, we need to mimic the behavior of the tree selection system where you have the hierarchy of the checkboxes. So, and it's a hard problem. So imagine that you have a state with the following hierarchy. So all the checkboxes are unchecked. So when you click on the B, you should also select the children as well. This is called propagation. And since the B is selected and B is a child of A, this means that A should be partially selected, which in the HTML we call indeterminate state. And if we uncheck the C, the B should also become partially selected. So in the requirements of the problem, so when we check the parent, we check all children. If we uncheck the parent, we uncheck all children. So, and if some children are checked, then it becomes partial. So notice that the input here is we get the paths. So ABC is basically a path to the in the tree, so which is available to us, and ABD and AE. So the final tree will be something like this that we need to construct. So there is no real DOM right now. We will need to kind of build a tree ourselves and represent it as a hierarchy. So then there is a second input, which is clicks. And the clicks just takes basically a single letter, and it's just a node on which we're clicking. So in this case, if you click on this tree, you will see that B, C, D will be selected, and A will be partially selected. And in order to solve this problem, we'll need to remember how the bubbling and the propagation works in the DOM API. So you know that when we click on the node, then we can propagate. It's not exactly the same as DOM, but we can propagate the event down to all the childrens and select them. And then we can bubble up the event to the parents and recalculate the status of the parent nodes. That's how we're going to approach this problem. So our plan should be here to create a tree-like structure that will support this hierarchy. Then we're going to build the tree from the input. Then we're going to handle the bubbling and propagation of the events. Then we will handle the clicks. And then we'll return the string output that is expected from the problem. Now let's jump to the next coding exercise, which is inside the tree select. Here, let's review what we already have in the scaffolding, and let me close the console. Okay, so here we have the selection status, which is described by these three types. This is selected, this is not selected, and this is partially selected. So, and also we have the constants that we can use throughout the code. Also, we have some scaffolding of the tree node. So our tree node can have an array of children. The default assigned status is not selected. And inside the constructor, we're declaring that each tree node has the name, and it also could have a parent. And then there is already provided toString method that allows us to stringify the node. So we don't need to implement the toString in this problem. Okay, so our first step will be to construct the tree from the paths. Remember that the paths are represented like this, so we can copy it here. So we need to create the node fruits, and then add the child node apple and banana, and then we create another node vegetables, and then the child carrot. So let's do this, but before that, let's complete the structure of the tree node. So first, we need a way to add the new children. So let's create a function called addChild, which takes the node, which is our tree node. And what this function does, it sets the parent property to this, so because this node becomes the parent of this node, and then it pushes the node to the children. So very simple method. And now let's create another method called updateStatus. So this we'll need in the future to recalculate the status of the node. So it doesn't take any arguments. What it does, it checks all the children and sees if all children are selected, then it means that the parent node should also be selected. If all the children are unselected, this means that this node should be also unselected. And if some of the children are selected, then we add the partial status. So let's check this. So first of all, let's verify that that we have zero nodes selected. So let's create a variable called none-selected. And in order to verify this, we can call this children. And then we can filter the values. And if there are some nodes that have the status which is not anything except the not selected, that means that we already have something selected. So that's how we filter this. So if node status not equals to not selected, so this will give us the non-empty nodes. Then we check the size of this, length, and if it equals to 0, this means that we don't have any children that are selected. The next check is the all selected. So if we have all the nodes selected, same thing. So we need to execute these children. Then we check that every element inside the array have the status equals to selected. Okay, so now we can have the simple conditioning. If non-selected, we update the status to equal not selected. Otherwise, if we have all nodes selected, then the status will be equal to selected. And the other case is the partial selection. Is this method clear to everyone? Okay.
So if
Yep.
you have no children, then you'd be none selected.
Yep.
Is the value.
So by default, we don't have any selection in the input, so we don't need to assume that there is an existing state. So the existing state is always non-selected.
Okay.
Okay, now we have our node, and we can create a method called createTree, which takes all the paths and initializes all the tree node. So let's do this. So we create a store, where we will store all our nodes in normalized state. And then we will create a root. So first, let's create a root node, and yeah. So the root node is essentially the utility node. We're not going to use it anyhow, but we need to put the we need to initialize the tree somehow. That's why we create a tree node, which we'll just call root, and it will not have any parents, but it will contain all the data from the paths. Then we'll initialize our store, which will be the map of the tree node. That's in this way we'll be able to quickly get any element from the normalized store, because every node will be so we'll basically store the map of every node. Okay, let's now iterate over the paths. So what I'm doing here, I iterate over the path, and our paths are split with a slash. So what we can do, we can split them using the JavaScript method called split. So, and also iterate over each token. Every time we execute the new path, we need to go back to root node. So let's create a pointer which links to the current node, which will be the root. And here inside the path, we're going to reset it every time we enter the new path. Okay. Now we have the token, and we can create a new node. But the token can already exist in our map, so we need to verify that we are not creating the node again. So for this, let's create a node, and then what we can do, we can check if the node store get token. Otherwise, we initiate a new node. Then we pass the string value, which is the token, which will act as an ID and the name, and then we pass the current parent. Okay, and now we created a node, or we fetched from the store, and if the store doesn't have the node right now, let's add this node to the store. So we're going to set token with node, and we're going to update the parent node. So the current add child, the newly created node. Okay, so the next step is to go inside the tree. So this means that our node will become the current pointer. So the next step is to update the current pointer to the node we fetched or created. Okay, that's how we construct the tree. Now let's return two values. So the first value we're going to return is the root, where we start the tree, and the second value is the store, where we store all the trees. All the nodes, sorry. Any questions?
Yes. Line 59, shouldn't that be... You're saying if the store already has
Yes,
the
that's
token.
correct. Thanks.
Yeah.
You're right. So if the store doesn't have the token, we need to add this. Good catch. Okay, so now we have the tree. And the next step is to implement the functions that allows us to bubble all the children, all the parents, and also all the children's. So that's what we call the bubble and propagate. So, and I suggest to use the generators here just to practice a little, because yeah, it's such a nice technology within the JavaScript. So essentially what we want to build, the bubble function will create a iterable object that will output all the parents in the line. So we can modify the parents later. So, and the propagate would output all the children's within the line. So, and in order to do this, we need to check if, let's implement the bubble first. So first, we check if the node has any parent. And if it does, then we call yield node. So the yield operator just outputs the value. And the cool thing about generators that it's very easy to write recursive methods with them. So in order to recursively call the generator, we can use the yield star and then call the bubble with the next node. So this means that this generator will be able to output all the nodes, all the parent nodes in the line. Same thing for propagate. So now we need to propagate, now we need to output all the children's from the target node. So for this, we're going to iterate over the child. And then yield every children. And the thing here, we also need to, because child node can also have the children property, so we're going to recursively call our generator. And this will allow us to see all the children in a line. Okay, now we have the bubble and the propagate functions. We are now ready to build the logic, so which is the clicking, creating the tree and clicking on the tree nodes. So let's handle this. So first, let's create our tree with the function that we're defined. So once the tree is created, we now need to handle the clicks. So we're going to iterate over the click. So of clicks. And since we created the store, which allows us to get the node by the token, so we can get the current node. Let's call it target. And then store get click. And here's our target. So now we need to verify that the target exists. And now we should be able to click on this. So when we're clicking, so first we propagate the event down. So this means that we need to iterate over all children. And then we call our generator, propagate, and then we pass the target. So now we can loop over all children. And we need to set the status. And one thing to note here, when we click on the parent, which is the target, we first need to update the parent status. So, and the logic is simple. If target status not equals to selected, then it means it should be selected. Otherwise, it's unselected. What's the constant name? Okay, not selected. Not selected. And now all the children will have the same status as the child, as the parent. So that's how we assign. All right. So we propagated the change down. Now we need to propagate change up. So let's iterate over all parents. And now we can call the method that we defined called update status. So the parent will take into account the updated children and update its own status. And at the end of this process, what we need to do, we need to take a root node and to string it to output the value. That's the implementation. So let's try to run a few tests to see if it works. Here's the first example. So it basically should render the tree unselected. Yep. So now we have all the trees constructed correctly, and it's unselected. So let's run another example where we select a few values. Here we render a tree with one root element, fruits, and two children, apple and banana, and we select the apple. So, and as a result, the apple should be selected and the fruits should be partially selected. So let's run it, and it doesn't work. So let's see why. So let's check the logic. Here inside the target, we get our target, then we update the target status. If target status is not equals to selected, then we use selected and not selected. And then we call the propagate and update the child status with the target status, and then we update each parent status. So for us to understand what is wrong, I think we need to debug a little and see where is the mistake. So first, let's verify that the bubble logic works correctly. Yeah, here's the mistake. So we need to output the node parent and then bubble from the next parent. So let's see if it's changed the picture. Yeah, now it works. Okay, so let's run more complex example where everything is selected. So let's run it. Yes, all selected. So I think we can now run the tests to double verify our implementation. Run, all tests pass. All right, congratulations. We solved all the problems. Let's recap what we've done. So we defined our constants with the selection status. We created a node and added the method called addChild to add the to update the children array. Then we created the update status to recalculate the status of the node. Then we created the function called createTree that iterates over the paths and constructs the full tree along with the general store, normalized store where we can get access of any node through the token. And then we created a bubble or propagate generators that just gives us a variable which we can use to loop over all the parents and all the children's. And then we clicked. We handled the clicks by getting the node for each click, and then updating the status. And then we propagated the event down to every children, and then bubble up the event to the parents. And the toString was provided to us, so we didn't do any work here. So congratulations, we completed the first part of the workshop, which is the vanilla coding. So the next section is called the UX problems. And since we already had a break, I think we can just go ahead without a break.
We're due for deck break, so maybe we'll do a break and then get everything cleaned up in here. So yeah, we'll be back in.
Just 5 minutes.
Okay. All right, welcome back. I hope you had a good break after the promise problem and after the tree select problem. Now we're going to decrease the complexity a little to give us a little breather. We're going to start with this next section, which is the components and UX problems. And what's the difference between the classic vanilla problems and the components problems? The main difference here is the way in the framework on how to attempt to solve these problems. So in terms of the requirements, we need to focus more on what components do, what are the user interaction we need to expect. Also, what is the data model or the property model of the component? What are the inputs and the outputs? What are the input properties and what is the state shape? So in terms of the API design, what do we expose to the external user of the component? And also, should our component be controlled or uncontrolled? Do we use event delegation to improve the performance, or do we use do we need to build the component stateful or not? So that's the questions that we're answering during when we solve the problems. Also, one big thing is the accessibility. So although this is not accessibility workshop, we're going to try to add some basic accessibility attributes. You don't need to know them like by heart, but I think knowing the basics will help you throughout your interview, and it will also give you bonus points if you're able to use them correctly. And yeah, and when you build the components, focus on minimal styles. Nobody needs your super shiny CSS with a 200 kilobyte CSS component. So just let's avoid building. Let's avoid having too much styles in our components. So what is the difference between solving the component problem in React and in vanilla? So the main difference is that React provides you the kind of the framework how to build these components. For instance, you have the render function that returns JSX where you write your template. You have the state management where you use the useState, useReducer, and other hooks. And you have the lifecycle methods to register the event listeners and so on. So in vanilla problems, we don't have in vanilla UX component, we don't have this. But it doesn't mean that we cannot bring this. So I'll show you the framework of how can you solve any component problem in vanilla by replicating some of the React lifecycle and bringing this into your code. So imagine that you're creating the component, and usually you create some class that contains with the constructor. So what if we could have the render method, which will basically call to some HTML method. So the toHTML method will declare the HTML template that we need to render, and the render element will basically insert this HTML into the DOM. Then we could use the inner HTML to set the HTML of the container. And once we render the element, we can also execute the after render effect, which will allow us to set some event listeners or update the state. So this is possible to build through in vanilla component building. So, and I'm going to show you the framework, and we're actually going to build this framework now. So also we also need a destroy method that allows us to clean up the DOM state after the component was removed. Okay, so let's first understand what are the property model for our future abstract components. So we're going to build the abstract component class that we're going to extend everywhere in the future components to avoid logic duplication. So first property that we need in the configuration object is the root. Where should we render our component? That's basically the target where we are mounting the component. Then we can provide some utility class name, which we can expose for the developer if they want to assign some custom class names. And then we also want to provide the listeners that the component should implement. So it can be click or mouse over, and the tag that will be used to create the container of the component. And notice that we use the tExtends object. So when we build our own component, we want to see a custom property model of the component. So this way, we can merge the default configuration with the user configuration, which allows us to build any extendable, to extend the component configuration, build any component with any specific properties that we want. So let's dive into the code now. And you'll need to open IDE and open the abstract component folder, component.ts. So now let's build our generic component. I already provided the type configuration here and also the default configuration. So the default configuration contains the class name array, which is empty, listeners, because by default we don't listen for any listeners, and the tag, which by default is div. And also we have a type component listener. It's when you register any listener on the component, we need a way to store them. So we're going to store this listener as the object, where the type is the type of the listener. It can be click, mouse, and any other mouse events. And the callback is the callback that we registered on the HTML element. One thing about the event system. So we want the user of abstract component, we want to force the user of abstract component to implement the event handling. So ideally, the user could provide events as an array that we want to listen for, and we automatically register them, assuming that these events exist on our component class. So in order to do this, what we're gonna do, we're gonna take the listeners array, and then we're going to convert them to the name of the class. So for instance, click will be converted to onClick, the mouse over will be converted to onMouseOver, and onKeyDown. So when the user of the component provides these listeners, our abstract component will be able to register these events, and it will assume that these handlers are implemented on the subclass. And we're going to automatically register them on the container element. And I know it's not clear right now, so let's dive into the code to properly understand that. Okay, so here we have the utility function that converts the type of the event to the proper naming. So it basically adds the on prefix to the type and uppercase the first letter of the event type. So the click will be converted to onClick. Okay, so let's implement the constructor first. So because the user will provide its own configuration, we're going to merge this configuration with the default one because some fields are optional. So we're going to use the default config that we set up, and then we're going to merge the user config. So this will be the component configuration. So also the container by default, it's going to be null because we haven't initialized any container yet. And the events array will be just empty because we haven't initialized any events yet. Okay, so the next, in the next lifecycle method is init. It's basically, it happens when we initiate the component first. Before rendering, we need to initiate all the things, create the elements, and create required elements, register the events, and so on. So let's do this. Let's complete the logic of this method. So first, we need to create a container where we will insert our component. So we're going to use the DOM API now. So let's use the container. And then we're going to use document create element. And then we pass the tag that we initiated. So this will create the HTML element with specified tag. Now the user of the abstract component can provide the class names. So let's add this class names to the container. So we're looping through the class names. And then we're just adding these class names to the container. Okay, So now we need to register all the listeners that the sub-component provides. So for this, we're going to loop through all the listeners that we have inside the configuration. So now we're going to convert the type into the expected class name that we should expect on our subtype component. Type. So it should, let's call it maybe class function. Okay, so now we're any component that will extend the class are expected to implement the event listeners that they provide. So what we can do, we can now get the function of this event listener from the class itself. So let's call it callback, and then we convert this as any to make sure that we can actually use the proper typing here. So we can temporarily convert this to string as event listener, or yeah, it just should be event listener. So now when we access the class using the class function variable as an index, and we should be able to get the callback. So as unknown and as record. Okay. So what if the user hasn't implemented the callback? And if this is not, if it's the case, then we need to throw an error. So if the callback equals to null, then we're going to throw. Okay. And one thing to note here, because because we also need to keep the context of when we're executing the callback, we also need to make sure that the event is binded to this class. Because if you use this inside the callback itself, we need to make sure we're preserving the class context. That's why we bind it to this.
Can you switch your coffee cup to the other side too when you have a second? Switch the coffee cup to the other side. Your coffee cup, sorry.
Oh.
There you go, yeah. Thanks.
All right. So now let's create the handler that we're gonna store on the class. So we pass the type and callback, and then we push the this to the events array. So we haven't registered the event listener yet. So let's do this. So we access our container, so which is the container element. And then we add the event listener with the type and the callback. So let's make sure that the container is here. Yes, so the container is created. And actually, I've noticed that we are not setting the container properly. So let's do this. This container equals to the element. And this same, let's reference it with this. Here, the TypeScript complains that listeners can be undefined, so let's initiate it with empty array. So now you see the system. So we go through the listeners array that the user provides as a user of component. Then we expect the user to implement each of the function, and then we automatically register the callbacks on the container level. For the after render, we don't do anything. So that's for the user of the component to decide what they want to do with after render. So for the render method, when we want to render the method called the render, we need to make sure that the container doesn't exist. So if it already exists, we need to destroy the container. So we checked if this container then we're going to remove this container from the DOM. Actually, we have this special lifecycle method called destroy for that. Okay. And now we need to reinitialize the container on render. And then we're going to use our container and set the inner HTML to the template that the user provides. So by calling this toHTML. So the treat toHTML method as a render method in the React class. So in older React, you use the kind of the class component, and the class component has a render method. So the toHTML acts the same way. You provide the raw HTML string, and then we just render it here inside the HTML. Okay, and here TypeScript is complaining that container might be null, but once we init the container, it should not be null. So I'm assuming that it's not null. Okay, so what happens on destroy? When we want to remove the container, this means that we need to remove the element from the DOM and also unregister all the events that we have on the container. So first, let's start with the handlers. And then our handler has a type and the callback. And what we want to do now, we want to access our container and remove event listener. And then we provide the type and a callback. And as a next step, we just remove the container itself from the DOM. Remove. And assign the null to the container. Okay, so now we've implemented the abstract component, and I know it's right now it's very abstract, but let's try to see how it actually works. So see, we have the component example here, and our component example extends the abstract component. So what it does, it registers the click event. And it also provides a custom state, which is the count. And now it implements the toHTML, which looks like a very JSX-like syntax, but it's actually HTML. And it can set some styles if we want. And it has two buttons, decrement and increment. And then we provide a function called onClick. Remember, we passed the click event here inside the listeners. So our abstract component will register this onClick on the container, so we'll be able to execute the onClick event. So now let's run the things. So for that, we're gonna execute. We need to go to the terminal and call ban def. This will run the def server, and you will be able to access this URL. And now find the abstract component inside the components, and here you will have the student vanilla. Open this. And you should see your problem here, but you don't see it. So let's see why. So for that, we're going to debug this. So nothing is being rendered. So let's see why it actually happens. Let's go back to the IDE and see what could be wrong with our abstract component. Let's hide this. OK, let's verify. So here is the init. We initiate the container with the provided configuration. So we also make sure that the config is initiated. Then we assign the correct class names. Then we go through the listeners. Yeah, the init phase seems to be correct. Let's verify here. So if on the render, if this event is initialized, then we just clean up the DOM. Then we call the init to initiate the container, and then we render the HTML. Okay, so let's try to see what is happening here, but just by debugging. So first of all, we need to verify that the constructor, that the render method works fine. So for that, we'll put debugger statement. And let's refresh the page. Command R. Here's our debugger. Let's try to see what is happening. So this container is null. For some reason, our container, okay, it actually should be null because we haven't called it yet.
Are you appending the child?
Oh
After
yeah.
you set the inner HTML?
Yeah,
append child?
yes, that's correct. So we forgot to append the container itself. Yes. Okay, let's drop this. So the next step on the render, so we use our config, and then we access the target where we need to append the element. So this is the root, and then we append the child. And then we pass our container. That's it. And let's open the our page again and see. And now it renders. So see now all events are handling. And now we can use this abstract component on every further problem that we have. And we're going to use it. So instead of duplicating the logic in every component, we're just going to extend this abstract component. Any questions in the room for the problem? So here is the usage example. We extend the abstract component, provide the click listener, then we handle the click. The click is automatically registered on the container. We provide the HTML, which looks like JSX, and then we create a new button and call render. That's how all the components will be built in our following exercises. Okay, if we're ready to dive to the next one, so let's solve a few TypeScript challenges. So for the next one, I think we can propose it as an exercise instead. So the solution for this one is stored in the repo. So try to solve it on your own, and see if you're going to resolve it, and then you'll be able to find the solution inside the repo. The same for the exclude challenge. So try to solve it on your own, and you'll find the solution inside the repo. So let's solve our first easy component problem. So this is called Accordion. So we need to build a component which basically looks like this. So it's just the accordion section which has the content inside, and when you click on the accordion header, you should be able to render the content. So if we go to the requirements, then the accordion itself is just a list of items. Each item will have the title that will act as a header, and each section can be expanded separately. And we need to make sure that we have the accessibility support with the keyboard navigation, and the hidden and shown properties are available to the screen reader. So from the API design, we get the items of the accordion item, so with the ID, title, and the content. So the ID is just a unique identifier of the item, the title is the header, and the content what we place inside the accordion. So this is an easy question, so we'll be able to solve it quite fast. So let's first see how can we solve it. So remember, on the interview, you can take any shortcut you want. But in this case, there is already Accordion natively supported inside the HTML. And this is the details tag. So the details allows us to set up the kind of the accordion style UI. So where the summary is the header, and everything after the summary will be inside the content. So, and I think we can start implementing this using our new abstract component. So let's jump to the accordion exercise. It's here. And each of the component problem will have the solution both in React and Vanilla. So you can choose which approach you want to solve. I'm going to rotate between React and Vanilla throughout the workshop. So, but I suggest for the next 5-6 problems, we're going to use the Vanilla approach instead, just to make sure you're comfortable with solving the component problems in Vanilla. So let's open the Accordion Vanilla file, And yeah, that's so we're basically extending our abstract component now. Oh, sorry. With the additional properties, which is the items. So the items are provided within the as a property, as a properties. Okay. So what is our next step? So let's define the constructor. And the constructor has the config, which takes the accordion props. And we actually don't need to implement this much. We can just actually leave it empty. So it's not needed here. And what is the next step? Next step is to build in the template. So here we're going to use the detail. Actually, let's create a separate function called get item template. And it will take the single accordion item and gives us this will give us the HTML of this accordion item. So we're going to return, use the template string, details. Then we're going to pass the summary. Then we pass the item dot title as the header. So that's our header of the accordion. And then we pass the content. So we can create a section and then pass the content inside. Item dot content. Okay. This is the single the single item, but we need to render multiple ones. And let's remember the semantic HTML. When we render multiple items in a list, we need to use the list item. So let's place it in a list item. And inside, now we can map our, so first let's define the simple unordered list tag here. Okay. And let's define the content variable. And now we can map our items, which we provided inside the config, into the HTML string. So, and we just pass the get template function inside the map. And we just join the string like this. And we pass the content inside. Okay. So see, we have now the JSX-like structure, which makes it very easy to build any component style. Now, if we go back to our website, let's see, and open the accordion.student file, and we also need to refresh the page. See, now we have the sections, which are already handled automatically by the HTML. So now, how can we make the sections look a little bit more like accordion? So now we need to do a little bit of styling. Let's use the class, and we already import the class, the object called CSS, which is just a CSS module within the file itself. So let's see how it's called actually. Imports. Yeah, it's called styles. Styles, and let's assign the class. So details. That should be on details. And then the summary, we can assign the class summary. Styles dot summary. Okay, so now let's get some styles done. So first of all, we probably want to remove this default marker. So for this, we can just use list style.none. Then we also want to make sure that our content is kind of expandable in an animated way. So for this, we're going to define the transition. So here we use the transition dot max height. Then let's provide some animation function, and by default, when the content is not opened, the max height will be 0. So now the details tag have a special attribute called open. So we can style the content and see what when the content is open. So when content is open, we can set the max height to be 500 pixels. And then we can set the scroll, the overflow Y to be scroll, to show the scroll. Okay? So now if we go back and update the page, so it almost works. So I will teach you one more thing. So see, why it works when we expanding, but it doesn't work when we closing. So there is a thing called discrete properties in CSS. So discrete properties, it's something that have a 0 or 1 state. For instance, display. It can be none, or you can display. Or overflow. It can be either hidden or other value. So something that you cannot kind of describe as a number, so which cannot be easily transitioned. So for this case, the CSS team, they developed one thing called content allow discrete property. So first of all, we want to animate content visibility. This is the internal CSS property that allows us to style the changes when things are being removed. And yep.
Can you dismiss that little pop-up that's down?
Yep.
There you go. Thanks.
And then we provide the animation function. And then we tell the CSS, hey browser, can you actually animate this property? I know that it's not by you cannot really animate this something that it's not cannot be represented as a number, but let's try this. And then the browser will try to automatically animate such property. So if we go back and then open this and close, see now when we close the section, what it does, it tries to animate the closing section because because we switch from the content visibility from display to none, and that's how the browser automatically handling this. And that's basically it. I don't think it makes sense to style this component. So CSS is relatively easy, but the main logic of Accordion is here. So see, we haven't written any specific JavaScript to handle the expansion of the element. So this is just the default HTML which is provided to us. So on the interview, try to use the native elements as much as possible. The cool thing about native elements is that they by default are accessible. So if I try to open it with the keyboard, it already works. So I don't need to do much. See? Okay, so do we have any questions in the chat, or we can jump to the next one?
Yep, don't see anything.
Okay. Congratulations on completing the first problem. So let's do the next one, which is the star rating. So the star rating is classic FAANG problem. So it's like often asked on the FAANG interview. So it's the medium complexity problem. And the idea here is that you need to render the 5 stars rating. So, and you should support uncontrolled and controlled modes. So this means that we should be able to either provide the state to the component, or the state can automatically control its own rating. Okay, so we should also support read-only mode, where we cannot click or change any rating at all. So for the visuals, we are provided with the star emoji that we can use, and if the rating is not active, then we'll just change the opacity of the star. Okay, so before we jump into this, let's understand what is the controlled and uncontrolled component. So control component is essentially the component that when we directly control the component, when the parent controls the component. So this means that we provide the value and also we provide the callback, what happens when the value changes. Uncontrolled components has its own state, so we cannot control the state of this component. This is usually useful on the forms where we don't really care about the specific component state, and then the state is set within the form itself. Okay, so let's jump to the code now and implement the star rating. So let's open vanilla star rating vanilla file, and here we have the same structure. So we have our star emoji, we have the star count, which is by default 5, and let's define the variables that we need. The first variable that we need is the value. So if the user wants to initialize the star rating with a specific value to make it controlled, and then on value change, which executed when we click on the star, and then read only if the component should be read only. Okay, let's initialize the constructor. So we call the super method. Then we pass the properties, and then let's provide the custom properties that we need to initialize. So the first one is the listeners. So we need to listen for the click event. Does anyone see the typo in my... Oh, okay. It's because we haven't wrapped it into the object. So now we provided the click event, and we're expected to implement the click event. Here is the function for this click event. Before we implement the onClick, let's actually render the template. So first, let's render the single star. To make our component more like accessible, you should use the closest possible accessible element. So the star rating itself acts as a radio group actually. So you can select one of the value within the radio group. So the ideal solution would include the input type radio. But to style input type radio in interview, it takes a while. So we can opt into the actually using the button instead, because the button is very easy to style, and then assigning the correct roles to make sure that element is accessible. So let's create the single star. For that, we're gonna pass the create the template string, and then have the button inside the star, and then we're gonna render the star inside. Okay. So what are the area properties that we need to set for each button? So first of all, our button will act as a radio. So this will tell the screen reader that this button acts as a radio button. So now also we're gonna set the area label, which will tell what this button does. We can say it's a rating of value. Okay. Also, we need to, because it's a radio, this means that it will have the selected status. So we need to provide the area selected. And the area is, the button is selected if the value equals to this value. So the current state. So if we selected 4, this means that if the radio represents the rating 4, it will be selected. Also, let's provide the data attribute. So somehow we need to, when we handle the event, we need to understand what is the rating we're trying to set. So in order to set some state on the component, we can use the property called the data properties on the DOM. So this will call data rating. So we pass the value inside. Okay, now we'll be able to access the rating when we click on the event. So what is missing? So the selected is here, and also let's add another variable called data checked to specify if we should render it as a checked state or not. So and the star is checked if the star value is less or equal the current rating. That's basically the code for the single star. Now we can render all the stars. So for this, we're gonna create the variable called stars, and then we're gonna create an array. So the array from takes two arguments. The first one is an array like. So here it will create an array of the length 5, and then we can map every value into the star. So here we pass the index, and then we call the get star. And the star accepts the value from 1 to 5, so we need to add the index plus 1 because the index starts from 0. Okay, and now we can render our stars. So we render the stars as a div element, and then stars. So right now it's not super accessible because it's just a div element. So let's assign the correct area roles inside. So first of all, because we use the radio inside a button, so our div will be a radio group. Okay, so and also we can provide the area label to tell what this component does. So in this case, it's star rating. And then we can also say if this component is read-only because we are passing the read-only variable. Area read-only. And that's it. Okay, so now we can test things. I see that we haven't. Yeah, let's use the template string here to make sure it's also rendered, and let's convert the stars to the string.
Would it be more accessible to use a form and input type radio?
Oh yeah, that's the better approach here. The only issue here is that the radio is very hard to style. So here the button is a bit easier to style. Okay, one thing that we forgot to assign the class, which will be our CSS star. The star class is already provided. It just basically removes the gives the some basic styles to the star, like sets the size and the pointer. Okay, so let's go back to our website and open star rating student file, and we are failing. So let's see why there is an error. Must call super constructor in derived class before accessing this. Okay, that makes sense. So inside the constructor, yeah, let's see why it's complaining. Star rating. Okay, that's because we need to refresh the page. We haven't got our code updated. So let's refresh the page. Yep. So now, as you can see, we have some stars, but nothing really happens. We cannot click on them. Let's now create a click event and handle it. So here we have our event that we're getting and our target on which element we click. So let's verify that the target is instance of HTML button element, and the target dataset. So the dataset allows us to get the data properties from the HTML. Rating is also set. Now we can assign the new value to the state, and we're going to convert the target dataset rating to the number, and we call the render method to refresh the star. And one thing we also have is the in the site config we pass the on value change event that happens when we change the rating. Okay, so if we open and refresh the page now, yeah, so the rating is set, but you see that by default it doesn't seem to. Okay, I think something is wrong with the styling. Let's see.
Because you're not getting a pointer on the stars either.
No, the pointer is set here.
No.
Oh yeah. Let's see. So this is the star rating, and this is our radio, and cursor is pointer. So this is set, but the opacity is overridden. Yeah, that's because we have the data checked attribute that checks that if the star is not checked, then the opacity is reduced. So let's see if we set the data checked here. And data checked is false everywhere. This means that we are calculating the data checked incorrectly. Let's verify the code. Okay, data checked if the value is less than. Okay. So if the current value is 4, and then the. Okay, that should be like this. No, that's actually correct.
It's supposed to be if it's equal to the value?
No, that's for the selected. Let's see. Let's refresh again.
I think you need active.
Let's see the styles. So no, we set the data checked full. If the false, then we override opacity.
Oh.
So this means the data checked attribute is calculated incorrectly. Let's see. Have we set the value to the state? Yes. So we set the value. So it should be the rating. Let's see. We can basically output this here inside the debugger. Value and this value. Let's refresh. Okay. We always, this value is always 0. So this means that we are incorrectly setting this value somewhere. And this is actually correct, yes. Let's see again. Maybe we are overriding the value somewhere. This value. And the listeners and the click, target, dataset rating. Okay, let's make sure that we are setting the correct value. And remove this console log statement. Refresh. So new values 4 and 5. That's actually what we're expected to have. Let's see the index plus 1, so this should be also correct. Interesting.
So in your solution, it's data active instead of data checked.
But even if you set the data
and
active,
and it's flipped around.
it shouldn't change anything.
No.
Oh yeah, that's because we now don't have the styles. So it doesn't really matter which
Okay.
data checked.
It doesn't matter. Okay.
So let's see. Okay, false, false, false. Let's debug it. So we put debugger here. Debugger. Oh, maybe we rendered the value. Okay, here is default value on value change, and then we call the render again. So this should be correct. I've put a debugger statement. So now we should be able to actually see what is going on. So here we clicked. Now the value is the 1, and this value is 3. So if value equal less or equals this value, that should be true. So let's see what's going on. Same thing here. And same thing here. So for these stars, that should be okay.
Just noticing, is the condition reversed? Should it be this dot value less than or equal to value?
You mean like that? No. So in debugger, it actually assigns the correct value. So let's remove some of the examples here. And refresh. Yeah, this one. Let's refresh. Now we have the, okay. Let's refresh again. So technically, when we executing this, it's actually false, but maybe we have some syntax issue here. Okay, let's debug it again. I'll put the source. Let's click on the 4. Now this condition should be true.
Someone in the chat said, should the class be styles.star?
Let's see. No, it's CSS. It's correct. It's actually assigns the correct class. It's just the attribute is wrong for some reason.
Yeah.
So this is our current value. So let's see what we're getting inside here, what the HTML template is resolved. So this is our stars. And let's stop here. I lost the breakpoint. Let's use debugger. Let's put a debugger here. Debugger. Disable the breakpoints. Enable again and see. Let's put the pointer. Okay, this is our stars that we are rendering. And see, the data checked is true. So data checked is true. That's what should render when we set this. And then we render all our stars. It feels like we're calling the render twice for some reason, but let's see. To HTML. Now the value is 0. This is probably because of the other component. Okay, I think I know what's happening. For some reason, our toHTML method called twice. So let's see what's going on here. So we import the abstract components, so this shouldn't be an issue. toHTML, see if it's executed just once, and then let's see if we properly initialize the star, so the star is initialized correctly. And then here we call the render value, and the renderer should re-render the star with the new value. Okay.
We're coming up on an hour. Should we take a 5-minute break now, and then you can debug it, and we'll finish when we come back?
Yep, let's go.
All right, let's do that.
Oh, that's a weird thing. All right, let's continue to debug our issue. Here, as you can see, if I refresh the page, for some reason, we get our values correctly set. So, but the stars are not assigned. And I think the reason is because we used here the assignment on star rating. So let's try to move this to the constructor instead. And then assign the value. Like this. And see if it works. So let's refresh the page. And now, as you can see, our star is getting correctly rendered. So the reason why it happens, which I assume that when we initialize the field like that, this initiation call is called after the constructor. And here, basically with the conflict, because every time we click on the new value, we create a new instance of the star, and it's basically getting reset. And because our example code, when it creates a new instance, it provides it within the constructor as a new value. And because we always reassign the value to 0 instead of using the value that we're getting from the parent. That's why it was always reverted to the 0. I hope it makes sense. So essentially, when we click on change value and we pass the value, this value is getting passed to the constructor later because the parent component controls the state of the component. And we haven't set this value here. That was the issue with the code. Okay. Let's jump to the next one. So, by the way, do we have any questions on the... All right, so the next is 2 interesting challenges that will allow you to learn about TypeScript type system a little bit more. So the first challenge called is never. So the idea of the is never is to detect if the provided type is the type never. And it's not that easy as you can expect. So for instance, we cannot just tell that if t extends never, then it's true, or otherwise false. And the reason for this is because t extends never doesn't produce any value. So the never in TypeScript is an empty union. So this means that the t extends never will never reach true or false statement. It will just be never. And if we try to execute this test case is never true, then it will basically fail. And in order to fix this, we have a workaround. So if this statement gives us the empty union, how can we convert this to some union? So the key trick here, we can wrap the our type into array. And now say something like this. So if it's a tuple with the never type inside, then it's true, otherwise false. That's how the TypeScript. So now TypeScript resolves this to the union instead of the never type. That's how can we kind of work around over this. So the key thing to remember here is never is just empty union. It doesn't produce anything. And in order to avoid this situation, we kind of need to wrap it into the tuple to make sure it's actually is a union of subtype. Okay. The next challenge is called any of. So the idea here is if in your provided tuple there is at least one truthy value, and the truthy value is something which is not 0, empty string, false, empty array, or empty object, then you need to return true, otherwise false. So let's try to implement this now. So we already have our kind of falsy type, which lists all the falsy types. So now let's create a utility type called isTruthy. And the idea is very simple. So we're just checking if the type that we're validating extends falsy value, then it's false, otherwise is true. And now we need to validate if any of the value within the tuple is if any of the value within the tuple is truthy, then we just return true. So this means that our any of accepts read-only any array because we are waiting for the tuple. And now we're going to use the magic extends keyword to get. Now we need to validate every item within the array. And in order to do this, we need to go through the array one by one. And for that, we're going to use a keyword called infer that allows us to get the first element of the array. And then we infer the rest of the array as a tail. So now, what do we do with that? So if the first element is truthy, then we should return true. Otherwise, we continue to search through the rest of the tail of the array. So we return the recursive type called anyOf, and we pass the tail inside. Okay, TypeScript is complaining. Let's see what is missing. Okay, here we're missing the extend statement. So if the isTruthy extends true, then we return true. Otherwise, we check the tail. One thing that it will not work if it's an empty object like this, then the result should be truthy because it's not a falsy. But in this case, it still fails to check this. Oh, actually, the empty object should be the falsy value as well. But we cannot validate. We cannot put it here in the union because basically any object extends this. So in order to do this, we can check if the type has any keys. If the type doesn't have any keys, then it means that it's an empty object. So, and in order to do this, we're going to modify our isTruthy statement. So if it's not the falsy value, we still need to validate if it's not the empty object. So what do? We check if key of t extends never. So then we return false. Otherwise, we return true. So here the way it works is if we don't have any keys on the object, then it will produce empty union. And if empty union is produced, then it will fall into the false branch. Otherwise, it's true. And now all our test cases passes. Okay, any questions on this one? All right, so let's move on to the taps problem. Yep.
One question, is infer a little bit like variable initialization?
Not really, but it doesn't really initialize any variable. It's more like initializing the generic. So in this case, it just allows us to reference the type of the first element type. So it doesn't really initialize any variable. It just gives us a way to reference the type of the specific element. Okay, so now we have the next problem, which is called tabs. And the idea here is we want to build the reusable tab component where we can have the tab list. And within this, each tab item will contain the HTML content that we want to render on click. So when we click on a specific tab, then we render the content. Only one panel will be, a tab panel will be visible at a time. So when we click on a specific tab, we replace the content fully. In terms of the data shape that we're receiving, so the data shape is very simple. It's the name of the tab and the content with this tab. So here, instead of re-rendering the whole component, we're gonna re-render only the partial, the panel itself, to avoid to avoid performance issues. So from the accessibility perspective, we need to make sure that our list of buttons has the correct role, which is tab list, and each button has the correct role as a tab, and our content is marked as the tab panel. That's the basic rules on API design for the tabs. If we're clear, I think we can start implementation. Let's go to the folder 25 called tabs and open the tabs.vanilla. So we still continue working with vanilla components. Okay, so first of all, let's review the property model. The single tab contains the name and the content, and the tab component accepts the default tab, which is the default open tab, and the target. The target is essentially where we should render our tab content. So if we want to render it somewhere within the page, then the user can provide the target HTML element and the array of tabs that we want to display. Okay, so let's first start with the constructor. We need to set up the state, and our state will contain a single value called the tab. We can just actually use just the value, which is a string. And then let's initialize the value. So by default, we should render the default tab which is provided within the configuration. And if it's not provided, then we're going to take the our tabs array inside the config, and then we're going to take the first element within tabs array and assign the default value to be the first element of the tabs. So that's it for the constructor. Now let's implement the rendering function for the getTab. So our single tab is very simple. It's just a button. And then we'll assign the ID, which will equals to the name of the tab. And then we'll assign the role, which is the tab. And one thing that we can provide for the screen readers is what is the area that is controlled by this button. So basically, we're saying if we click on this button, this area will be changed. So for this, we're gonna use the special area tag called area controls. And then we need to provide an ID of our future tab panel. So for now, I'm just putting the placeholder called tab panel. Okay. Inside the tab, we're going to render the text, which is just the name of the tab. And we also need to provide the area selected to tell if the tab is selected, and the tab is selected if the current value is equals to the name. And also, once we click on the tab, we need to access what the tab which was selected, and we can provide the data attribute called data tab, and equals to the name. So that's it for the tab component, for the tab button. So now let's render the list of the tabs. So for this, let's create the list called unordered list, and let's create a tab content. So we'll create a variable tabs, and then we're going to map all our available tabs and then pass this function called getTab. As you can see, the approach to solve any component is the same. Then we're joining and rendering the tab list here. Tabs. And let's also wrap it into the Li item tag. Okay. And if in order to render this into the as a raw list, then we should assign the correct flexbox style. Let's use the our CX tool to merge the classes, and then use the flex style to apply the flex row gap 8 style. So this will essentially create the row of the buttons with the gap 8 pixels between them. So let's see what we've got. Open the website, open the tabs, open the student vanilla, refresh the page. So cannot read property for of undefined. Let's see if we assigned the value correctly. So here we need to make sure that the getTab keeps the context, so we convert it to the arrow function. Refresh the page. Now we see that our tabs are rendered, so we have the buttons, but we don't have any content. So now it's time to render the content. So remember, the user can provide the target where we need to render the content, but if it's not provided, then we need to create our own tab panel. So for this, let's create the variable called panel. And if the panel is provided within the configuration, then we don't do anything. Otherwise, we create a section with ID which is equal to tab panel. Tab panel. And we also assign the correct role. So in this case, it is the tab panel. Okay. And this will be our section element. So we can also provide the area attribute called area labeled by, which essentially will link the user to the tab, which will to the tab button that we defined. So in this case, it will be tab and then our tab ID. This dot value. Good. And if the section is here, if we created a section component, let's render it as well. So we passed the panel here. Okay, so now the section element will be created, but we haven't yet rendered anything. So in our after render hook, now we need to be able to render the tab content. But before we do this, we need to implement the method called activate. So basically, it takes the tab and renders the content within the tab panel. So let's do this. So what it does, it gets the panel element from the either from the config, this config target, or we need to query it from the container. This container, actually we can just use document get element by ID and use the tab panel as an ID. Okay, so now we have our panel initialized. Now we need to get the content that we want to render. In this case, it's that we need to go through all available tabs. And then find the tab that matches the name. So let's see. So not the name, tab. So if the content is available, then what we do, we take our tab panel. In this case, it's element, inner HTML, and then we set the content. And then we also want to set the attribute called area labeled by. So the area labeled by just tells by which button the current tab panel is being controlled. So here, now on the after render, we should be able to activate the default tab that we selected. And if we render the content now, you see the content is rendered, but nothing happens here if we click on the buttons. That's because we haven't handled the click. So now we go into the click. And do the same check. If target instance of HTML element and target dataset tab, then we activate the tab. Okay, so now let's check if it works. And let's check if we set the value within the activate. Yes, we also need to set the value. This value equals to tab. That's it. Okay, refresh the page. Now let's click on elements, and now we're getting our tabs working, and the tab panel is getting updated. Okay, so any questions on this problem? All right. Nope. Okay. Let's move to the slides. Our next problem is the...
Hang on, you're, Did it, go into extending, is it extending instead of mirroring?
Probably. Should I stop extending?
Yeah, you want to mirror. Little purple button at the very top of your screen. Or the little icon, choose mirror. Hey,
Okay.
there we go.
Okay, the next problem is called Dialog. So this is not particularly complex problem if you know the right keywords, I would say. So the thing is, the Dialog itself is quite hard in terms of implementation because you need to handle multiple things in terms of accessibility. The first thing is the focus management. When you open the Dialog, you need to make sure you move the user focus into the dialog area. And also you need to handle escape keys and the backdrop that is created by the dialog. It should not be accessible by the mouse clicks, so other elements should not receive any events. So, and if you're trying to build it with the simple HTML, it's actually pretty hard without because you will need to write some JavaScript to handle all these things. But I would like to propose the shortcut which you can use. So essentially, we need to build the element with the two buttons, confirm and cancel, and some content inside. What can we do? So apparently, our HTML is our friend here. The dialog exists as the standard HTML element that we can use and utilize. It already handles everything for us. So the focus trapping, escape key, the background, event blocking, and so on. So it's all already available and the dialog element has a good browser support. So it's already a standard that we can use to solve the problems. And if you don't know this, you will have to implement everything yourself on the interview. So now, knowing this, we'll be able to quite fast actually build the whole dialog element. So the API that we should provide should have just two functions, show and close for the external developers. And these functions already exist on the dialog element itself. We can just basically call them. It's a show model and close. And there is also a close event that we can listen if we want to handle some logic, if we want to execute some logic when the dialog is closing. Okay, so let's implement this now as the next problem. Let's open the dialog vanilla in the Pro 26 dialog. We'll continue to work with the vanilla components for a while now. Okay. So let's first start with the simple HTML that we want to render. So the idea here is the HTML is super basic. It's going to be just a dialog element. And then we're going to have the section with the user content that user sets. And we're going to have two buttons. That the user can click. So the section is basically the user content, and we are providing the content as a part of the properties, and also the two other properties is on confirm and on cancel. So the property model is very basic. Here, inside the section, we're going to render the config.content. And here inside the buttons, we have the confirm and cancel. And in order to handle the event that are coming from the buttons, we're going to assign the data action confirm and cancel. Okay, so now if we try to render things, nothing will happen because dialog is closed. So in order to open this, we need to implement the open and the close. But first, we need to get the element, the dialog element. So we already have the field called dialog element, but it's not initialized. So after we render the component, we want to fetch this element and just store as a property to basically enable easy access. So for this, we can just query the element dialog from our container. This, I think it's missing the private property, right? And now we can access our dialog element. So on open, what we need to do, we just reference our dialog and then click, choose the show model. That's it. We will show our dialog element. And on close, we just use the again our dialog element and call close. So now we can probably try to render things and see if it works. So go back to the website. Let's select the tab. And open the dialog element. student vanilla. Let's refresh the page and click Open Dialog. Now the dialog appears, although because we use the reset CSS, it's not centered. So let's quickly center it. To do this, let's assign the class and use the css.container. And the container class is super simple. If you open, so basically we just need to make sure that the margin is set to auto to align the dialog. And let's try to refresh and open dialog, and now it's centered. Okay, so we can now make it a little bit more nice. So here we use the CX tool. Yeah, just let's provide some basic padding. And add the class name here. Flex. Okay. So now it should look a little bit nicer. So let's refresh, open. Yep, so this is our dialog. As you can see, if we already have the focus trap set up for us, we don't need to do anything. If we click escape, the dialog automatically closes. So now we need to handle the events that are happening on the confirm and cancel. So, and this is super easy. So here we have the onClick method that we're handling. So let's get our target. And if target instance of HTML element and the target, so we set up the data property called action, dataset action. Now then we can handle the action. So let's fetch our action. And now let's do the if condition on if action equals to confirm. We need to handle the, we need to access our config. And then we need to click, use the onConfirm and execute the handler. That's basically the user function. Otherwise, we just use this config on cancel. And once we clicked on the button, we just want to close the dialog, so we call the close. So now let's refresh, open the dialog, confirm, you get the confirmation, closing. So let's click cancel, click on confirmation, closing. So same thing, I can try to call the keyboard, and keyboard focusing works fine as well. That's it. We could go a very complex way and implement the whole visibility stuff ourselves, but using the standard API helps us to simplify the whole problem a lot. Okay, any questions? Good? Now, let's solve a few more TypeScript challenges. Let's open the, so the next challenge called lookup. So essentially you have the two types that share the same property called type. And you need to build a lookup type that allows you to look up that allows you to get the specific type from the union. So you can have like the union of 100 animals here, and if you provide the correct type, it should extract the correct type from the union. Going back, open the folder 26, lookup challenge. And here we're accepting the union. So type lookup. So we're accepting an object that has the type field as required. And then we're accepting the union that we need to look for. And the only thing that we need to do here is to check if the object extends the following type. So what we do, we're telling the TypeScript, hey TypeScript, is this object is similar to this thing? So basically type and the union were provided. And then if it's true, then the TypeScript is able to return the type which matches the following condition. Otherwise, we just return never. Okay? And all of this cases passes. That's another TypeScript challenge. Any questions on this one? Good. Let's solve another one, which is called return type. And the idea is very simple. We need to get the return type from the function. And and it's actually default built-in type inside the TypeScript. And I'll show you that it's not a magic actually. So let's define our type called return type. And the return type accepts the generic, which should represent the function with any type, any arguments, and then with any return type. And how do we how can we get the return type from the function? And the idea is very simple. We're going to use infer. So we're going to tell TypeScript, hey TypeScript, is T matches the following structure? So, and the structure is the same as what we're referring here. So here I'm asking if the type extends the function, and I'm asking TypeScript to get the return type from this function for me. And if that's the case, then I can output the return. Otherwise, it just outputs never. That's how the return type works in the TypeScript, by basically inferring the return value. Any questions? Okay. So let's jump to the next problem. So this will be the first kind of hard problem on the harder side. So this is called Tooltip. That's the problem will require some thinking how properly to implement this. So essentially, we need to build a tooltip that when we hover over the trigger element, we show the tooltip. And the basic requirements is not very hard. So we need to provide the position where the tooltip will appear. It can be top, bottom, left, or right. So, but the main challenge will be to implement the auto positioning. So if we don't have any space within the viewport, this means that we need to adjust the tooltip based on the available space around the trigger element. And the concept of the tip could be just text for the problem, for the exercise. Okay, so let's first understand how we determine how can we actually render the tooltip. So we're going to use the mouse enter and mouse leave event to track the entrance of the mouse pointer on the trigger element. And we're going to use focus in and focus out to track the focus on the element through the keyboard. And we're going to use the key down event to track the escape if we want to hide the tooltip. So the tooltip itself should have the absolute positioning adjusted relative to the container. So, and the container will be the wrapper element that will wrap our trigger and the tooltip. So the auto positioning will automatically calculate the available space, and we're going to review the slides before we actually implement the auto positioning. That's it. So that's the basic requirements. So in terms of the how we handle the positioning. So first of all, there are 4 main positions that are available to render the tooltip. So imagine that you have the viewport, and viewport calculation starts from 0 from the left top corner. So the Y is at the bottom and the X is the most right. In order to render the tooltip on the left, we need to take the coordinate, the left coordinate of the trigger element, and then subtract the tooltip width. So we can properly render the whole tooltip on the left side of the trigger element. And the Y position will be the Y position of the trigger element, because we render things from top to bottom. Now, if we want to render things on the top, we need to take the left position of the trigger element, and for the Y position, we're taking the top position and subtracting the tooltip height. So it starts from the corner of the viewport, from the top of the viewport to the trigger element, because we render things from top to bottom. All right, and if you want to render this thing on the right side, then we're taking the right side point of the trigger element and render it from left to right. And the Y point will be the trigger top, basically the top value of the trigger element. Then, if you want to render things at the bottom, we're gonna take the bottom position of the trigger element, and X will be the left position of the trigger element. That's the logic how we render the static tooltip. So I think we can now jump to the solution and first implement the static positioning without handling the automatic positioning. So open the tooltip, the problem 29. And here inside this, we already have the properties set up. So the position could be top, bottom, left, right, and auto. So the children, sorry, we actually need to open a vanilla file, not React one. The position could be top, bottom, left, right, and auto. The candidate position is essentially what we just described. It's where we can start rendering the tooltip. So if we render at the top, then it will have its own X and Y coordinate, as well as the bottom, left, and right. So we created a separate type for that. And the tooltip props accepts the following. So it's the position, the children element, like the content of the tooltip, then and the boundary. So the children is actually the target. It's what we are wrapping inside into the tooltip, and the content is what we have inside the tooltip. And the boundary element is essentially our viewport. By default, it's going to be the document body, but in some cases, we want to limit the viewport to some specific element. In this case, we can provide the boundary as a separate HTML element. Also, we created the constant called positions. Based on the position, we apply a specific CSS class with the styles. These classes are not implemented, so we're going to implement them. In terms of if the position is after, we don't apply any specific class, so it should be just null. Because we determine the position automatically based on the calculations. That's why we apply the empty class. Okay, so we will skip the getAutoPositioning method for now. So let's spark this out, and let's start implementing the tooltip itself. So the tooltip will have the variable called ID. It's basically the ID of the tooltip, so we can easily access it by the ID. Then we have the tooltip element that we store to update the class list. And then we set up the constructor and provide the events that we want to listen. So this is mouse enter and mouse leave for listening for the mouse events, focus in and focus out for the keyboard events, and key down for handling the escape key. The CSS container just makes the container have to have the position relative. So we can absolutely position the tooltip based according to the container. And the tooltip already have some basic styles provided with the width and the background yellow, so nothing really fancy. Okay, so let's render our tooltip. So the tooltip itself is very simple. It's just a div with a role tooltip. And inside, we render the content. This config dot content.
I'm closing code around the role.
After tooltip.
Oh, yeah.
Equals otherwise.
Okay. So now we have our 2HTML ready. So the next thing to be done, because we are wrapping the children element into the tooltip, we need to make sure that we render this children element inside our container. So what we're going to do, we're going to access our container and then append child. In this case, it's going to be our tooltip element. Config, oh, sorry, not the tooltip, but the children element that we're wrapping. So basically the trigger element. And also we want to query our tooltip. So we can use document get element by ID, then fetch the ID of the tooltip. And here, let's set the ID of the tooltip as well. This ID. That's it. So now, if we try to open the website, so let's do this. Let's switch the tab. Refresh the page and open tooltip. Student vanilla. Okay, now we see that we are kind of rendering things, but we are rendering them by default, and they always appear at the top. And that's expected because we're not assigning any class, and by default our tooltip is visible. So let's make sure that now we hide this by default. So here we also forgot to provide the tooltip class. One sec, let's do this. Provide the class equals to this tooltip. Okay, if we refresh the page, let's see. Okay, sorry. This should be the class name. css.tooltip. So now our tooltip should disappear because by default the tooltip has the display none. Let's implement the fixed positioning first. When we hover on the top, the tooltip should appear on the top, and the same for the bottom, left, and right positioning. So let's do this.
One question about why not use the native popover?
Oh yeah, we can use the native popover, but you cannot customize it. So if you want to render the custom HTML content, you still need to use the custom tooltip component. Okay, so let's now implement two methods called showTooltip and hiTooltip. So essentially what this method does, it assigns the position class to the tooltip and change the display to block to make sure that we switch from none to block. So let's do this. For the showTooltip, first we're going to access our tooltip element. Then we're going to access the position, which will equal to this config position. And now we can access the position class, which will be position class, and use our constant with the positions, and then type the position. So this will give us the class name. So here, if the position is not defined, let's use the top positioning by default. Okay. So now, before we show the tooltip, we need to make sure that we remove other positioning classes that were applied before. So we're going to iterate over all available classes inside the position. And then we're going to remove the class, the class list, the class name from the class list. Okay. And now we can assign the correct position class. So tooltip, class list, add the position class, and also tooltip, style, display, and then we just call block. Okay, so now we can call this show tooltip method, and let's implement the high tooltip. So it's the same thing here. We access this tooltip, and instead we just override the display to none. Now we can show and hide tooltips based on the mouse over and mouse leave. Okay, so on mouse enter, we call the show tooltip. The same thing happens on focus in with the keyboard, and on mouse leave, we call hide tooltip, as well as on focus out from the keyboard. Okay, so now if we go back and refresh the page, now our tooltip renders on the hover, and if we try to access it with keyboard, it's as well renders. But the positioning is incorrect because we haven't implemented the CSS classes. So let's do this. Let's open the tooltip. So if the class is top, then the top should be 0. And remember, we discussed that we need to move the element by 100% of its height. So we're going to transform, translate y minus 100%. So for the bottom, it's the same logic. We place the tooltip at the bottom of the trigger element, and then we transform. Actually, we don't need to transform here, I think. But let's see. Then on the left, we just use the left 0 and then transform x minus 100% to move it left by the tooltip width. Same thing for the right. We just use right, 0, and that's it. Let's see if it works. Let's refresh the page. So now the top one renders correctly, the bottom one doesn't render correctly. Yes, that's because we need to still transform it and move it to the bottom. Left one works as expected, and the right one also, we should move it by the through the transform. So here 100% and here 100%. Okay. Let's refresh the page. Yep, and now all the tooltips are rendered correctly. Cool. Now it's time for the most complex part, which is auto positioning. So let's get back to our slides. How do we handle the auto positioning? So imagine that we have our candidates positions that we discussed previously. That's the one. Left, top, right, and bottom. So what we do, we need to check all the candidate positions and see if we are within the viewport boundaries. So viewport boundaries are defined by the left and right coordinates. So imagine that you have the canvas, and the viewport takes the part of this canvas. So the viewport left represents the left boundary of the canvas, and the viewport right is the right boundary of the canvas. And these properties are available for the method called getBoundingClideRect, which is by default is available in every HTML element. So what we need to check if the viewport, if our tooltip is within left boundary and the right. So we check the left boundary and the right, and bottom and the top. In case of the top position here in the example, we see that the left, we are within the left boundary, but we are out of the top boundary, so we cannot render it here. So, and if, for the sake of interest, if we validate all the conditions, we see that most of the condition passes, but because we're outside of the top boundary, this means that we cannot render it here. And same thing if we try to render on the right. And if we're not within the viewport boundary on the right, so we're not able to render it here. And if now, since we're within the viewport boundary of X and Y, this means that the tooltip can be placed here. That's how we handle the auto positioning. Okay, so let's jump to the code and implement this. But before we do this, any questions? Okay. Let's open the tooltip.vanilla again and implement the auto positioning method. So here we have our 4 candidates, left, top, right, and bottom. So let's start with the top. So also, to get the coordinates, we need to convert the elements, which is the tooltip, the trigger element, and the boundary into the bounding client rectangles. And to do this, we can just map them. So let's call it TCB, and then we can just create a tuple and map it. Map element get bounding client rect. Now we have all the boxes that we need. Okay, so remember what we discussed. In order to render tooltip at the top, our X position should be the left coordinate of the container, and our Y position should be the top coordinate of the container minus the tooltip height. So we can render it on the top. Now let's do the right positioning. On the right, we are taking the right coordinate of the container. It's here. And then we need to plus the table width, the tooltip width. And the Y positioning should be C top, because we are rendering from the top corner to the bottom corner. Okay, so, and if you want to render element at the bottom, this means that we need to check. We need to the X position will be the left side of the container, so we access C left, and the Y we access C bottom. Now, if we want to render things on the left, we take the C left boundary minus the T width, because we want to render it from left to right. And I just noticed the mistake. The here we just should use just C right, because we render already from left to right. And here the Y position of the left side should be just C top. That's it. That's our candidates. So now we need to verify if these candidates are within the boundaries of the element. And for this, we're going to use our boundary rect and verify if the coordinates are within these boundaries, the left, right, top, and bottom. So let's create the method called fit and check if the X and Y are within the left and right boundaries, as well as the top and bottom. So first we create is fit horizontally, and now we're checking if X is within the the boundary, so it should be more or equal the left boundary. Be left. And x should be less or equal be the right boundary. And because we also need to add the width of the tooltip that we're rendering, because we're rendering from left to right. So let's add it. Tooltip width. So we are just adding this width to the x position. And now we need to check if we're fitting the tooltip vertically. So we're checking y is more or equals than the boundary top. So basically checking the top boundary here. And y is less or equal boundary bottom, and we need to add the tooltip height. And if both conditions passes, then this means that we are within the right boundaries. Okay, so now we can verify that if at least one candidate passes the test. So for this, let's create a variable called candidate. Then we take all the positions that are candidates, and then we find the element that fits the criteria. And if the candidate is found, we return the candidate position. Otherwise, we assign the default value to the top. Okay, let's integrate this method now into the into our show tooltip. So here, by default, if the position is equals to auto, then we're gonna call our get after positioning. Otherwise, we're gonna try to access the positions class variable. Okay, the get auto positioning accepts three fields. The first one is the tooltip element that we store. The second one is the container, where we store the trigger element and the tooltip. And the last one is the boundary element. So the boundary element by default is provided within the configuration. So this is called boundary. And if it's not provided, we assign the viewport document body as the default viewport. Okay, so now we can test the things and see if it actually works. So let's go back to our website. Let's refresh the page. So now, let's refresh it again. Weirdly enough, let's see. Let's open the example. So here, as I see, the after positioning doesn't work correctly, but let's see what's the values being assigned. It actually assigns the top as a default value. Let's verify that we have the correct setup. So here's the get auto positioning class, and otherwise this config position. That sounds good. Let's verify if our method is at least executed, so we can verify it here. So let's console log candidate and see if it works. Yeah, so it's essentially resolved to the top, and this is a good because it just means that we have some mistake in our calculations. So let's verify that we're calculating things correctly. So first, let's check the candidates. So the top should start on the left, and C top we subtract the height. Then we check the right, should start on the right. And as well as we use the C-top positioning. For the bottom, it should start on the left. And the Y should be the C bottom. And if we do the left, then our starting point is C left plus minus the width. And this seems to be correct. Now let's verify if the fit method is correct. So our fit should be, our X should be more or than B left. And also our X plus T plus width should be less than B right. That also seems to be correct. Let's verify the Y. So it should be more than the B top. So the top area and as well, it should be less than B bottom. Okay, so this looks correct to me, but maybe we're not passing the correct boundary here. So in this case, this is the, let's verify that's the boundary setup. And let's use the debugger. And let's refresh the page and see what's going on. Top. Let's move for debug. So the position should be auto, show the element will be called. The tooltip is assigned. The container element is also assigned. The boundary is set up. So we should have the boundary element as well. And the position class is top. Okay, now I think now we want to debug our calculations. So here, let's make sure we have the correct order of the elements. So tooltip, container, and boundary element. And here it should be tooltip, container, and the boundary element. Okay. Let's put the debugger here. And refresh the page. So we get our, okay. One thing which is concerning is that our tooltip has the 0 values. So this shouldn't be the case. This just means that the tooltip is not rendered yet, so we cannot calculate the positioning correctly. So let's go back to the code and see why it can be the reason. Okay, so here when we try to calculate the position, okay, I know the reason, because we're not displaying the tooltip, so the box is not initialized. So that's the actual reason. So we need to display it to the block before we can actually calculate the correct positioning. So let's refresh the page and see if it helped. Okay, it's still not the case. Let's see if the box is still initialized. So let's put debugger here and see the box.
You have to step through that line.
Yep, 1 second. Oh. So the box. Now it's initialized, at least correctly, which is good. So this means that we solved at least one problem. So now let's verify why it's resolving to this state. So let's debug the positions. So do we fit horizontally on the top positioning? So we check the border left. So and we should fit according to the current styles. And do we fit on the left as well? It works because we should fit on the left. And then let's check the Y. So the Y is 44, and it should be more than top. And it's not. So we actually should not fit vertically. This condition should fail, and we should have the different candidate be unassigned. So let's verify. So the condition is false, so that's the correct behavior. And now we are checking the right candidate. So the right candidate,
Can you command plus that just
Yep.
a little bit, just to, yeah, perfect, thank you.
so we're checking the right candidate. The X is 600 pixels, and the left is, okay, we're within the boundaries, and then we check the right one, and we are within the boundaries. So the horizontal on the right matches, and then is fit vertically. We check the Y equals to the top. Oh, I know what's the reason. So there is a precision point that we need to fix as well. So let's go back. Here, in our calculations, we need to use the math sale. And here, the math sale as well. Okay, let's refresh the page. And see what is the class that is being assigned. We can solve for why it's not correctly positioned later. So let's see, Tooltip. Okay, actually the class is not set. That's why the element is not rendered correctly. So let's check why the class is not set. Let's solve another problem. So here we display the block, and then we removing all the classes, and then we're trying to assign the correct class. So let's verify that the position class is set. Console log position class. Refresh. So the position class is right, left. Oh, okay. So the issue is we need to call the positions and then choose the position class we're assigning, like this. And it's right now complaining because we cannot index because the position class is any. So what we can do, we can say that it's a position type. And we can also verify that, okay. Yeah, and here, instead of assigning the specific class, we use the position instead. Okay, now the TypeScript happy, and I guess this should work. So let's try to refresh the page again. So top edge, yeah, now we are moving to the right. So right edge, see, we don't have any space on the top, on the right, and on the bottom, so we move to the right. Bottom edge, we render on the top. Left edge, we also render on the top, and center the top by default. So now we solve for after positioning. And that was the hardest part of this problem. Let's go back to the slides. And do we have any questions?
We're due for just a tech break to cut a recording, so
Okay.
when you do, how much do you have left of the Tooltip one?
Sorry?
How much do you have left of the Tooltip one? Is that,
So we've got, let me see, 1, 2, 3,
I
for
meant how
problems.
much of the tooltip example do you have left? Like, is this wrapping up the tooltip one?
Yes, that's the end for the tooltip.
Okay, yeah, so I don't see any questions, so maybe we'll just take like a quick 5-minute
Yep.
break to do our little tech, and then we'll come back and wrap up with what we can.
Okay, so let's continue the workshop. So we've just implemented the tooltip, which was quite a problem. So it's time to go to the next one. Okay, so the next one is data table. So we're going to implement a generic data table that accepts any structured data, and we should also support the sorting, pagination, and the filtering. So in terms of the state management, we accept the configuration of the columns, and we use these columns to render the headers as well as the cell content. So the pagination itself is implemented through the buttons. So we'll have the buttons called next and the previous, and we'll be able to paginate on the available pages. The sorting and the filtering done on the client side, so we're not making any server requests for that. So we're basically sorting the data that is loaded on the client. All right. So before, this is how the ideal use case would look like. So we get some data from the server, and configuration from the user, and then we're able to render the things. Before we dive into the coding question itself, let's define the property model for our table. So the problem statement mentions that it should accept any type of the data. So this means that the user can provide the column configuration. So this means that the first property that we need is the columns. So it will be an array, and each column will contain the ID, which will be a unique identifier of the column, the name, which we'll place in the header of the table, and then the renderer. So the renderer is basically the React function that renders the cell content. And yes, I mentioned React because we're going to implement this problem in React. And the data source is the abstract data source that gives us the data. It's just a data provider. So the data source itself is already provided to us. The thing that it does, it has the next method that allows us to fetch the data. So the data can come from any source, from the server, for the static. So our table will just use the data source as the way to get the data. And this data source will also have the total number of pages that we can access, and also the page size that we're expecting to pass. All right. So the next property that we expose to the developer is the search. So the developer can can pass the custom search function. If we try to search for the specific row within a table, then we can execute the search function to filter the results. The comparator is basically used when we do the sorting. So by default, it's already provided to us. We just need to use it as a property. So the comparator is the function that takes the column ID and the direction of the sorting, which can be ascending, descending, or none. And then it creates the comparator that is passed inside the sort function. So we will do the sorting, but the comparator is provided to us. That's the API design of the table. And the data source concept is actually well known across the industry. It's used mostly in all table libraries. So essentially, the data source is an interface which can be implemented in many ways. So it can access the API, static data, or some files. And we don't care about the implementation itself. We only care about the data that comes through the next method. So we're a consumer of this data. And the basic types that we will need is the data source, which is already provided. And as I mentioned, it will have three properties: page size, pages, and next. And then we have the table column, which will have the ID, name, the renderer function that takes the item, and then render the node. And then we have a sorting, which is the ascending, descending, and none. The none is default order by default. Okay, so now overall the table properties will look like that. So it's the columns, the data source, the search function, and the comparator. So that's it. I think we can start coding the problem. This will be the first problem we are solving in React. So open the problem number 30 and the table.react file. So there is already some scaffolding around. So for instance, all the types are already provided. And there is a utility constant called next direction. So essentially it takes the key as the direction and it tells us the next direction that should be applied. So in case of none, it's ascending. In case of ascending, it's descending. In case of descending, we should reset the ordering. Also, we have the type sort, which we'll use for the state management. So we're going to store the current sort state inside the variable. And the sort state will include the ID of the column we are currently sorting and the direction of the sort. And here, all the properties that we are passing inside the table. Notice that we're using the generic here inside the table component. So this means that the data that's coming to the table will always have the ID property. That's the limitation that we set on the incoming data. So we need the ID property to do some basic scaffolding. For instance, if the search function is not provided, then we're going to use ID on each data value to see if it matches the basic search condition. Okay, so let's first set up the state. So what we need to within our state is the query that the user writes in the search bar. So let's create a simple React state. So by default, it's empty. Also, we'll need the data that we're gonna fetch from the store. Oh, sorry, from the data source. And by default, it's going to be empty array. Then we're gonna store the sort state. And by default, we can assign just null. And here in the use state, we use the T as the generic type to make sure that the data is also typed. And then in the use state here, we use the T sort and the T as a type. And also because we assign the default value as null, it also can be null. And before we jump to the next section, we also need to store the current page that we are displaying. So let's create another variable called current page, set current page, and also use state, which will be 0. Okay, so now it's time to fetch our initial data. So let's do this. Let's create a use effect. And then now we need to fetch the data. So to fetch the data, we need to use the data source and then pass and use next variable. So the page will be the current page. So let's also add this to the dependency array here and also the data source as well. So we pass the current page. And let's use default page size, which will be 5 for now. Okay, so the data source returns the promise, so we can handle this promise. So if the promise is successful, we get our data. So what we need to do, we need to set the data. So we use our hook to set the data. And we merge the arrays. So we add the data first and then pass the data to the end of the array. Okay, so the next call is to handle what if we've failed to fetch the data. So we pass for now, let's just add the function that just throws an error in case if something goes wrong. Throw error. So that's it. Now we're able to fetch our data. So the only issue with the use effect right now is what if we already stored the data for the current page? So this means that we shouldn't do any call. So to verify this, what we can do, we can check if the data length is more or equals to the data source page size. Actually, let's create a variable called the page size, and it will be equal to 5 by default. And then we pass the variable here, and then we check if the current page multiplied by the page size. So if, for instance, the page is 1 and plus 1, so our total number of elements should be 10. So we're verifying if the data length is more than the 10 elements, or more or equals than the 10 elements. In this case, we can say that the data is in cache, and we can just return. Okay, so also we want to update the dependencies. Use the data.length. And one thing to be aware of is the weird React behavior. So when you're in dev mode, the use effect is executed twice. So this means that this call will be executed twice. And in order to prevent this, we're going to create a variable. So this is only the development environment behavior, and it's well-known React behavior for the development mode. So let's create a variable .cancelled, and it's going to be false. And once the effect is executed, we're going to assign it to cancel to true. And if the call is not cancelled, we then fetch the data. So let's see. Okay, if not cancelled, set data. So this will prevent from fetching the double amount of data. So this happens on the React initialization. So unfortunately, this is an issue for a long time, and we need to be aware of this. Okay, so now we are fetching the data. Let's render this. So let's render our data. Here in the compute, so the compute is our future function that will apply the filtering, sorting, and slicing. So for now, let's return the data from the state. That's it. And create a variable called chunk and call our compute. Okay, so what our table should have? The first thing is we should have the table tag. So we're going to utilize the standard HTML tables to render this. So we also have the t-head tag, which allows to render the header. And we also have the t row here because we have a single row of the heading. And now we can we can map through the columns, and then access the column, and then render the t heading with the specific name. Okay, so this will give us the heading of the table. Now we want to render the body of the table. So let's create a content variable, and then we're going to map the chunk of the data that we have. So map value, and then return tr. So here we're creating the single row of the table. Now we want to map all cells according to the columns. So we're gonna access our columns .map. and we pass the function inside, and now we're taking our column and returning the table cell, which is represented by TD tag. And then inside, we used our column and the renderer function, and they passed a single data value inside the renderer function, which is the value. Okay, so now if we render the content here in the tBody, so let's use the tag tBody, and now we place the content. We should be able to see the data coming in. So let's go back to the website now. The problem called table, and let's use student React file and refresh the page. Yep, as you can see, our table is now being rendered. So there is no, so because the user provides the configuration of the columns, and let's see how it actually looks in the example. So if you open the React example, this is how our columns are defined. So there's an ID in the name, and then the renderer function. So this provides a great flexibility because the user of our table can render the cell in the way that they want. So providing the standard formatting and the text that they want to see. Okay, so the remaining part is the sorting, filtering, and and the pagination. So let's implement this. So first, let's implement this search. So because it's the most obvious thing that is left. Okay. So inside the search handler, so we have the data in the query which is coming in. If the search handler function is provided within the properties, then we just going to return the result of this function, and we are passing the query and the data inside. If it's not provided, then we'll provide the default function. So we're gonna filter the data and check if any ID includes the query. That's where we'll write in the search bar. And we're passing the search handler inside the our compute function. So here in the compute, first we create a variable .filtered, and then pass the data inside the search handler, data and the query. And now we return the filtered data instead. So let's see. Okay. So now let's add the search box that we can use to search through the table. So here at the bottom, let's create the simple div. Then we're going to have the let's have the button and multiply by 2. So this will be previous page, next page, and let's create the input type text. And the value of the input will be the query that we're setting. Query. And when we change the query, we're going to pass our setQuery method. So here we call the event, and then we use the setQuery to set the query, eTarget.value. Okay, so now when we set the query, we should be able to execute the search because we filter it in the compute. One thing to note, though, we need to make sure that also the query is not empty. So if query is if query is empty, then we just return data instead. Okay, so let's go back to the page, and refresh. And now if I try to search for Apple, you see the search works, and Microsoft, and so on. So we also can search for the price, and it also works because the search query is provided by the example. Cool. So then the next step is to implement the pagination. So the previous and next, they don't actually work. So let's implement this. So first of all, let's handle the next and previous call. So when we click next, then we just need to increase the page size by 1. So set current page, page plus 1. And here, in case of the previous case, we just do -1. And in order to prevent the situation where we go over the allowed values, here we can provide a disabled property and check already for the if the current page is 0, then this means that we cannot go beyond that. So, and if the current page equals to the data source page size, pages, then we -1, then the next button will be disabled as well. And then on click, so for the previous, we call the previous function. For the next, we call next function. All right, so now if we go back, let's see if this works. So next, see the new data is coming. We probably want to display the loading state in some form. So let's just do the very simple thing here at below. Let's create a loading state. We can create a new variable called isLoading. Set isLoading. And then the use state equals to false. And when we load in the data, which is here, we set loading to true. And when we loaded the data or have an error, we use the finally and set loading is false. So with this, we are able to show the loading state. Let's check. So this could be just a very simple string. So for instance, is loading, then we output is loading. Otherwise, just empty. Okay, and refresh. So now we're able to load the data. The only thing you see that right now it's not really pagination because we are just append the data at the bottom. So we're gonna fix it, but first let's also implement the sorting. So the sorting is the next step. So the sorting itself is executed when we click on any header here on symbol, name, price, and change. So in order to kind of save on the event handling, so we can use the event delegation technique, and instead we can apply the on-click event on the T row of the T heading. So instead of creating the multiple event handlers for each column, so we can just use onSort here and catch the event that bubbled up from the heading. So that's called the event delegation technique. So on the sort, what we're gonna do, we'll need to access we'll need to check if target is instance of HTML element and the target dataset ID is present. If it's the case, Then we're gonna create have the constant const ID, target dataset ID, and we're gonna set the sorting direction. So we use the set sort, and the first variable which we're passing is ID, and then the direction. So the direction will be, we have our constant utility constant that we can use to determine the next direction. And we're saying if the data, so if sort state is initialized, then we access sort dot direction. Otherwise, we just use the next direction. None. That's how we initialize it. And here, the TypeScript is complaining that the string cannot be key of t, so we can help TypeScript to prove it that it can be key of t. So by casting this, and the direction here, it's complaining that let's see. So it should be just dir, which is direction. Okay, so now we're setting the sorting state correctly, and so now we need to execute our sorting with the specified competitor. So first we filter the data. So now if the sort is available, let's create a constant called sorted. So if sort is available, then if sort is available and comparator is available, then we're gonna use this the data that we filtered and output the two sorted array, and we're gonna execute our comparator, provide the column ID and the direction. Sort and sort direction. So still complaining. Let's see. Type none is not okay. Let's ignore this warning for now and see if it just works or not. So we pass our competitor. Oh, we also want to verify if the direction is not equals to none. So here we also verify if sort direction, because if the direction is none, then we should not sort any data. That's it. And otherwise, we just use the filter data without sorting. Okay, now we return the sorted data. And let's see if it works. So let's refresh. So let's try to run the sort, and it doesn't work. So let's see why it doesn't work. This is because we haven't assigned the ID to the heading. So let's assign the data ID equals to CID and refresh the page. And now our sorting works. So on every column. So the last remaining bit that we have is the pagination. So as you can see, all the data is applied below. So we need to implement the slicing. For this, we're going to slice using our current page. So our sorted, we're going to slice from the current page. Multiplied by the page size. and we'll finish on current page. Multiplied na page size plus page size. Okay, let's see if it works. Actually, we can just use this current page plus 1. Let's refresh. And now if we append the data, so new data is coming, and all our pagination works as expected. And if we try to filter, then it works. Okay, so this is the table component. I hope you like the implementation of this. And do we have any questions in the chat or in the room?
Nope.
Sounds good. So in the next section, so let's jump to the slides again. Okay, so next we have a few TypeScript challenges to resolve. So the first one is called parameters. Essentially, we need to get the type of the parameters within the function. So we have the function foo, and we want to extract the parameter type. That basically replicates the parameter utility type within that we have in TypeScript. So let's go to the parameters challenge. And here we accept, as usual, we create a generic, and we're telling that this generic should accept the function with any number of arguments, and which returns any. And here we're going to use the same technique that we use for return type, but instead we're going to write if f extends the function, and we then ask TypeScript to infer the type of the parameters. And then we're going to return this type. So let's call it params. And if the provided function matches the expected condition, we extract the variables. And all the tests pass. So it's the same approach through the infer. And for the next challenge, I suggest that you guys try to do the little exercise and try to implement on your own. So you'll find the solution within the GitHub repo. It's in 32, the evaded challenge 16. Okay, so now we have one more problem, which is called rigid thread. And essentially, we just want to render the kind of the thread component with the comments that looks like this. And as you can see, it's very similar what we've done with Accordion, but instead it's the instead we're still using the detail stack to render the comments. So for this exercise, I suggest that you guys will solve it on your own as well. It's relatively simple comparing to the previous one, but now we can go through the slides and see how we can actually solve it. So yeah, let's go ahead. So first, what is the data shape that we're expecting? So the data shape is the following. So our comment contains the nickname, the text, the date, and replies. And replies are the basically nested comments. That's the comments that we expect to render. And in order to render this, we can use the simple detail stack. This will allow us to do the nesting. So as you can see, the details have the replies as a header. And if the comment has a replies, then we render the unordered list with all the comments inside. So this is the basic recursive rendering in React. That's how would you would approach this problem. And since we need some root component to start rendering, so we'll just create a simple root component, and we iterate over the comments and render each comment. All right, so the next component we'll solve together. This is called the gallery component. We're gonna build the custom gallery which accepts the URLs of the images, and then we'll have the next and previous buttons that allows us to go through each image on the inside the gallery. So you will see this is how it will work. So basically 2 buttons with the image inside. In terms of the approach, how we're gonna solve it, the first thing that we're checking, we need to make sure that we cannot go past the to 0 index, as well as past the last element inside the image array. We're also gonna try to optimize the gallery and load the images lazily. So this means that when the gallery component is initialized, we only render the images that are at least 1 item away from being loaded. So that's how we can save some traffic. Yep, that's the general approach. And let's implement this in React. Open the gallery component folder here and the gallery.react. And let's start solving things. So first of all, we need to track the index, which is the current index that we are displaying on the gallery, and then we set the state for the set current index, and we initialize it to 0 by default. Then we need to have the navigation handlers, which are the previous and the next. So let's initialize it. Previous, and this the handler itself is very easy. What it does, it basically sets the current index for the previous. It just subtracts 1 from the current index. For the next, it adds 1 to the current index. That's the way how the previous and next works. Okay, so if no images were provided, then we just return the default state, which is nothing to display. Okay, now we want to render the gallery itself. The way the gallery will work is the following. So we have the 2 buttons that we display. So the button 1, which is the previous, and the list of the items that we want to display. And the next and the button to display the next image. So on click on this one, we're going to handle the previous, and on click on this button, we're going to handle next. And the button should be disabled if the current page is 0. And for the next button, it's the same logic. So if the current index is equals to the image's length minus 1, this means that we reach the end. Okay. So now we have now we need to render the list of images. Here we loop through the images and map them to the Li items because we use the unordered list, and then we use the src, and then we check the current index. So here, let's not implement any optimization yet. So we just render the image. That's it, and we provide the default alt attribute to make the image more accessible. Okay, so if we go to the website now And let's open the gallery component. Which is this student.react. And refresh the page. You will see that we're just rendering the items as a column. So let's change that. Let's apply the flex styling. So here we're gonna apply the class name, cx flex dot. Let's actually use the other class name instead. So cx.css image list. Okay. So for the button, we're gonna apply the class called CSS button, and the same way we do here. And let's see what we've got here. So now let's apply the flex styling to make sure that our images are displayed in the row. So we open the gallery style. So the image list, now we apply the flex. So display flex direction row. And if we look how it looks nice right now, so we have the each image is rendered in a row. So, but it's not what we expect. So in order for the image to look like what we expect, we need to make sure that the image itself is not shrinkable. So by default, the flex item is shrinkable. So if we say that the image width, the minimal width should be 100%, and the minimal height should be the 100% of the container. And let's limit the gallery for this exercise to be max height of 500 pixels, and refresh the page. Okay, the style is not applied. Let's see what's why it's not applied. Oh, because we forgot to apply it on the list items. So 1 second, let's apply it. So the class name of the li item will be CSS image. Okay, let's refresh the page. So now we have a single image on the screen. We still have an issue with the previous and next button, but we can resolve it. Now we want to limit displaying only one picture. So for this, on the gallery, we're going to apply the overflow.hidden. And now we have only one picture displayed. Now let's fix the previous and the next button. So for this, we need to apply the absolute positioning for both. Position absolute, and then we apply the height 100%. Let's refresh. Now we have the next and the previous. And let's make the following. So the first button, so the first child, should have the left alignment. So the second, the last child should have the right alignment. So now we have the previous and the next button displayed. So now let's make sure we handle them properly. So in the gallery of React, let's make sure we assign the clicks. And now, in order for this to work, we need to apply the transformation and basically move the whole list on the left. So it will be like a frame that we're moving. So the way it's going to work let's see. Let's go back to the slides real quick. So the way it's going to work is we have the list rendered, and we have the viewport. And on the viewport, we can only see one image. So if we start translating item to the left, we'll be able to see the other images as well. So we rendered them all as a row, and then we apply the transformation to render them. So that's so we basically need to apply the transform translate x based on the page size. So let's do this. Let's create the new style called transform. And then, based on the current index, we'll move the items to the left. So, and let's apply this to the list itself. So, style, transform. Okay. So, if we go back to the website with our example. If we click next, now the images changes, but there is no animations. So let's do this. Let's have the animation set up. Here in the image list, let's apply the transition to the transform. And if we refresh the page, now all our images moves smoothly. So that's the gallery exercise. So you don't need to have the perfect styling here, but at least this basic handling of the disabled states and the animation states is already should be provided with the problem. Okay.
So, I mean, that might be a good spot to end for the day. I mean,
yeah, sounds good.
Yeah, just because I don't think we'd be able to make it all the way to toast anyway, and then we can pick up in the morning. So, so yeah, by the way, there was, before we cut, there was one question that regarding pagination.
Mm-hmm.
What pagination technique do you recommend, offset or where clause?
Where clause?
Yeah, I was trying to figure out what the I don't know what where clause means.
So the offset is a common technique to use the pagination. So you actually don't choose the approach of the pagination. Usually it's the server who decides. So, and the UI works with what server decides. And if we're talking about the backend, so most of the like libraries and the GraphQLs, they use the offset type of the pagination, but it doesn't really matter for the UI. UI
Oh, I guess they're talking like by where clause they mean in terms of like a DB, like must be like in the query, like using offsets in the query versus like a where clause to select the data. So I think that's what they mean by where clause.
I'm not pretty sure.
Yeah. But yeah, I think you answered it there though. So being that the back end decides. Okay. Well, thanks everyone for hanging on for the marathon. We will be back tomorrow. We'll see you then.